Okay, so we are back with another marathon. Okay, so now in this one means because earlier, like last year, what we were doing, we were going with the exactly line means NCRT line by line. So what happens in that one? Lot of irrelevant lines also we were reading. So a lot of time was consumed because now we have less time and we have to do all the chapters. So what happens? What I observed in the previous one, some chapters done in the much detail, some chapters done in the less details. So what I have taken this time, I have taken all the solid examples, all the important points of the NCRT. Even this time I have included exemplar also, and then all these things are taken in the your PPT version. So this way we will cover NCRT also and exemplar also, solved example also, as well as NCRT exercise questions also taken. Not all the questions, very selective questions taken, because we cannot do everything in this. Okay, whatever I feel that yes, this can be asked this time, all those things are taken. Okay, because initially I thought I will open the NCRT and then and then I remembered that yes, last year or what happened that some chapters taken a lot of time, but some chapters are having like 20 pages. Scrolling those pages takes a lot of time. Okay, so just selected the important and taken the screenshot and taken here. Okay, and all chapter wise. So let's start this thing. First chapter that we are having is the unit dimension measurement. Quite important chapter, and out of this chapter we can expect at least 2 to 3 questions minimum. And you will, if you have solved the exemplar, you will see lot of time questions they are asking from the exemplars as it is also. That's why I have taken some questions from the exemplar as well as exercise. First thing coming from the significant figure. If you see, I will slightly zoom it. Okay, significant figure. I will explain theory also a little bit, because maybe some people already know full theoretical points, and some people are thinking that yes, in this 6 hour. So yes, in this 6 hour also you are going to get lot of information. And you will see when you will sit in your final examination that yes, so many questions appeared from there, because NT is not going to make any questions from anywhere. They will take the reference of either NCRT, either solved example, either exercise questions, either your exemplar question. So first question coming here, each side of the cube is 7.2. Okay, now here it is written, side is given in this one. And listen, whenever questions of significant figure is there, mostly you don't have to do any calculation. Okay, no need of any calculation. Okay, you have to just check the significant figure. So you can say this side is this. Okay, this one is the side 7.203. If you check here, how many significant figures are there in this one? 7.203. You can say there are the 4 significant figure in this one. Okay, 4 significant figures are there, and you have to remember, okay, that in the plus and minus, okay, you have to consider least number of decimal place. Okay, least number of decimal place must be considered. Okay, in the plus and minus operation whenever you are doing. Okay, if you are doing multiplication and division, then in the multiplication and division you need to consider your significant figure here. Okay, so now we can see in this one, how many significant figure in this one? You can say 4. So your answer must be having the 4. Okay, here we have to take least number of decimal places, and here you will take the least number of significant figure. Okay, now we can see that in this one, when you will write the surface area of the cube is 6a square. So you can say whatever the calculation is coming, you will be having the options. You have to check by the option, like 4 significant figure, your answer should be having the 4 significant figure. So you can say yes, in this is my answer, and it is having 4 significant figure. Option will be there, calculation not needed. Okay, you don't, mostly 90% times you don't have to do the calculation. Don't you waste your time in the calculation. You have to just go by the rules. plus and minus, then you have to consider the decimal places, and if multiplication division, you have to consider your significant figure. Same is the for volume. For the volume, okay, again options will be there. This is the your okay, options are not there. So you can say volume will be a cube. You don't have to multiply, okay. No need of multiplication. You will just check the okay, your significant figures. Some objective also are kept so that you can tick, okay. Now, so what is the thing here in this first question we learned that first question we got here, that if plus and minus is there, we have to, okay, consider least number of decimal places. Otherwise we have to keep okay, I think I need to, okay. Then comes next question is, okay, they have asked this okay, earlier. Okay, Jaswant, okay, I think if any of your friend is there, you can ask, because I don't have the updated one. Now, they are saying that here in this one, if you see that this is the mass, okay, 5.74 gram. I think it is visible now, visible to everyone. Okay, so 5.74 gram of substance, and this is the volume given. Okay, now you can clearly see here, this is having how many significant figure? You can see 3 significant figure are in this one, and this is having 2 significant figure. I hope everyone is able to find the significant figure. Yes, that 5.74, all non-zero are significant, all non-zero. Here you can say yes, okay, these 3 significant figure, here 2 significant figure. As per the previous rule just now I have discussed, okay, what you have to consider, they are asking the density. You know, density is just mass by volume, but are you going to divide, this is the like 5.74 divided by 1.2. do you have to divide, because options will be there? No need of division, don't waste time there, just you have to check the least number of significant figure. Your answer must be having least number of significant figure, okay. You can see this one is having the 3 significant figure, this one is having 2 significant figure. Your answer must be having 2 significant figure. So out of the 4 options, which one is having 2 significant figure, you can take. Okay, rarely it will happen, you have to do the calculation. I'm not saying that, okay, sometimes maybe you have to do the calculation, you can do the calculation, okay, but not always, okay. So we can say this is the your okay, answer here in this one. This is the answer, and this answer is having how many? 2 significant figure. Okay, you have to consider always least. Least means this is having 3, this is having 2. Least is what? 2. So answer must be having the 2 significant figure. Clear? Yes. Okay. Now we'll take the next question here. Okay. I hope this one is clear. If you're not, you can quickly say, I will explain, okay, because chances of these questions are more to be asked, similar to that, similar pattern will be there, okay. At the, okay, after the NEET examination, you can check also how many questions came from this file, okay. Almost all the questions will be seen to you. Now here I have taken this, okay, line from the NCERT, you have to, okay. This is very important for the statement type question. Okay, statement type question, or they can ask assertion region type question from here. A dimensionally correct equation need not to be, okay, need not exactly an exact equation. Means dimensionally correct may not be 100% correct, okay. Dimensionally correct may not be 100% correct, okay. Like if I say, example I'm giving here, T equal to root L by G. This formula is dimensionally correct. Yes, dimensionally correct, this formula, Hana? But if I say this is numerically correct, this is the correct formula, no, this is not the correct formula. What the correct formula everyone knows, because this is the easiest formula in the physics. 2 pi root of L by G is the correct formula. This formula is correct numerically also and dimensionally also. So a dimensionally correct formula may not be always correct. That is the meaning of first line, okay? Because dimensions analysis does not tell you any information of the constant. Whatever the dimensionless constants are there, you will not get that information, okay? So remember, this is for the statement type questions or assertion region type questions. The dimensionally correct equation need not be actually an exact equation, okay? maybe sometimes true and sometimes may not be true. If there is no constant in that expression, it can be true, but not always true. Then they are saying a dimensionally wrong, okay, but if any formula is dimensionally not correct, if dimensionally not correct, then 100% it cannot be correct anyway, because any formula to be correct, okay, if you want any formula, any correct formula, okay, how to be numerically correct, numerically plus dimensionally correct, okay. So any correct formula you have to take, it should be numerically correct as well as dimensionally correct. So if it is not numerically correct, it is not the correct formula. It is not dimensionally correct, it is not the correct formula. Okay, clear this thing? If it is only dimensionally correct, it is a correct formula, it may not be the correct formula. So you will remember this line, okay, that any correct formula, I'm writing here, okay, again this thing, any correct formula, okay, any correct formula is composed of two parameters you have to check. One is the numerical value, okay, numerically correct, okay, numerically, plus it have to be dimensionally correct, okay. Any formula which is, if you are saying the correct, it have to be numerically correct as well as dimensionally correct, okay. If I say only dimensionally correct formula is correct formula, no, okay. If dimensionally wrong, it cannot be correct, okay. That is the meaning of this thing. If you remember this line, you will be able to answer any type of statement anywhere. Yes, any correct formula have to be numerically as well as dimensionally correct. If a formula is not, if formula is dimensionally wrong, 100% this formula is wrong. That this line is saying a dimensionally wrong, okay, incorrect, wrong, incorrect or inconsistent equation must be wrong, okay. I hope this line is clear for the assertion region. I will move further. This is the one question I have taken again from the NCERT. They are saying SI unit of energy is this, and then that of speed is this, and which of the formula for kinetic energy can you rule out on the basis of dimensional analysis? We can write any of our formula, okay, how to be dimensionally correct always, okay. Now you can easily see here, if you say all the options in this one, first one is written m square v cube. You can see, yes, dimensions you will check. I'm not going to check here, okay, not possible. This is the ma is the force, not possible, okay. This one is also not possible. So these two are possible. One is this, one is this, and you know that exact formula out of these two options, if you have to choose, option will be what? B, okay. This will be the B option. Clear? Any problem? This file I will ask them to send, okay, so that and to upload also in all the campus, that if you want to see something out of this, you can see, because in the quick time, if you want to revise, this will be the better version, okay, because you cannot do whole NCERT or exemplar as of now. This is clear now? Both side dimension you have to check. Both side dimension you have to check, okay. This is known as principle of homogeneity. Okay, Jaswant, I will ask someone, okay. I will reply in the okay, I will message you. So only those quantities can be added or subtracted which are dimensionally same. Like if you see here, this is the energy, but this is the force. This cannot be correct, okay. Only you can add those quantities which are dimensionally same, okay. I will take one question on that one. Now, these questions are taken from the exemplar, okay, means may not be somewhat visible, okay. So these are from exemplar here. Now, if you say first one is there, which of the following pairs have the same dimensions, okay, you have to find dimension of this first one term and the second term. Torque and work, you know that yes, this is having the same dimension. By this time you should be able to tell at least this thing, that yes, torque and work have the same dimension. If you have problem, I will say, but I don't think, okay, this thing you should be okay. Everyone have this, the torque, work, energy, any type of energy, potential energy, kinetic energy, okay. Then they're saying energy and power. You know, energy and power cannot be same, because power is what? Energy by time. It cannot be same, okay, not possible. Force and momentum, not possible, you know, okay. And pressure energy also not possible. So which pair is having the same dimension? You can say first pair is having the same dimension. Okay, yes, I will suggest you people to revise this file, maybe not one time, 2-3 times. Okay, because sometimes whatever we feel that yes, these questions can be asked, these can be asked, and if you have solved NCRT, you have solved the exemplar, then you will automatically get to know the importance of this file, that yes, all important questions are taken. If solved, then you will know. If not solved, okay, then you have to believe yes, it is important. But if anyone who have solved the questions of exemplar or NCRT, you'll say yes, all good questions are taken from there, are not taken very lengthy because they are not asking. Okay, they will send. Okay, now okay, okay. Now, so we can say we will go by the significant figure. This question was about the area equal to L into B. We can okay multiply, but listen, wherever they use the appropriate significant figure, this line is given, it means they are not asking about the calculation part here. So we can say we can multiply, okay, not in this question, but okay, if needed, and whatever is there we can do, and then we can calculate our error. Okay, but this question was about the significant figure. It appears it is the question of error. This question appears that it is the question of error. Okay, a lot of people think that in exemplar they have given the tough questions. Yes, this question is tough if you think it is the question of error, but this is not the question of error. This is the some just significant figure. Only here in this option only 3 significant figure given. All remaining 4 options you don't have 3 significant figure. Right? Then again, this question from the exemplar here, they are saying P, Q, R are physical quantities having different dimension. Just now I said only you can add those quantities which are dimensionally same. Dimensionally same quantities can be added or subtracted. Okay. Multiplication, there is no problem. Multiplication you can do, but only those quantities you can add or subtract which are dimensionally same. Okay, you have to remember this line. Okay. Only those quantities can be added or subtracted which are dimensionally same. Okay, okay. So same dimensions can be added. Again, I'm writing also here. Same dimensions can be added or subtracted. Can be added or subtracted. Okay. Same dimensions can be added or subtracted. Okay, I'm repeating the same important line 3-4 times so that okay, when you will sit in the examination, these words will sound, oh, same dimension only can be added or subtracted. Okay, multiplication, no problem, you can multiply anything. Like if I say okay, mass and acceleration, you multiply, you get the force. Okay, so multiplication, division is no, okay, no issue. But plus and minus, you have to remember only those quantities can be added or subtracted which are dimensionally same. Okay, so coming further, this question they are saying PQR are the okay PQR different dimensions, and if different dimensions, then direct plus or minus not possible between the PQ and R. Direct plus minus not possible. Multiplication you can do, division you can do, but direct plus minus you cannot do. Let's check here. Okay, they are saying which of the following can never be meaningful quantity, can never be meaningful quantity. Which cannot be meaningful quantity? In which you are doing direct plus or minus. If you do direct plus or minus, that cannot be meaningful. Okay, you remember, if you are doing direct plus and minus, it cannot be meaningful. So first we can say P minus Q, you are doing directly this one, P minus Q by R, direct. Okay, you are subtracting, it cannot be meaningful. Okay, so this is the one thing cannot be meaningful. PQ minus R, P and Q multiplying and then subtracting R. Here might be, because this is not the direct plus minus. I'm saying direct plus minus you cannot do. Multiplication of P and Q, multiplication of P and Q can be same as R. So it is possible. Only you have to remember direct plus minus not possible. Direct plus minus you cannot do. So this one is possible and not possible. Yes, this can be meaningful. Okay, this can be meaningful, but there is no direct plus minus. Here also in the third you see that there is no direct plus minus. In this one there is no direct plus minus between the PQR. But if you see E, again there is the direct plus minus. Okay, direct plus is there, direct plus is not possible, direct minus is not possible between the different quantities. I hope this question you can take. Lot of people do mistakes when okay, this question we ask in our examination, lot of time we have asked. Okay, I thought to keep this question again. Okay, if it appears like this, okay, direct plus minus not possible. Okay, you have to just keep this thing in the mind. Okay, now we'll go for next question. This is also from the your okay uh, exemplar here. They are saying photon is, I have given the solution also, means I have taken from there so that you will not okay uh, because in this one I'm writing in that I have to erase, it is not saving. Okay, I tried earlier. So photon is a quantum of radiation with the energy equal to h nu, where nu is the frequency, h is the Planck constant, and you all know Planck constant is all time favorite there. Lot of time they are asking the Planck constant. But listen, Planck constant, everyone knows that yes, this is the dimension of Planck constant. We can easily figure out the dimension. So maybe they might change. I thought this question to be good. Okay, and of course, NTA may not okay make their own questions. Sometimes they feel that we are making the question becomes wrong. They will copy from where exemplar is there. So in this one, they are saying Planck constant dimension. Everyone knows we can solve using this one. E divided by nu. E is nothing but the energy. Energy is simply ml2 t minus 2 divided by your okay frequency t minus 1, and this will become ml2 t minus 1. Okay. This is clear. Planck constant we can find equal to h nu formula we have used here. Okay, E equal to h nu. So you can say h becomes basically E divided by nu. Nu is the frequency. Energy is ml2 t minus 2 divided by t minus 1. Yes. Okay. Now these four pairs are there, and out of these four we have to check which is having the same dimension. So I have written here, you know that dimension of linear impulse. Everyone knows linear impulse coming in the Newton's law. Okay, that force into time. Force is mlt minus 2 into t. This becomes mlt minus 1. Okay, and mlt minus 1 is not possible. Okay, angular impulse you got in the chapter of rotation. Okay, here you will get okay, terms will be also revised. Angular impulse, because I don't think till now you got anywhere angular impulse dimension you have written, because okay, rarely we talk about this angular impulse. Till now, have you written the dimension of angular impulse? We write the impulse lot of time. We write the momentum. We write the angular momentum. Angular impulse generally, okay, we are not using. So you can say this is the your I omega, and then you can say we got this one, and this one is matching here. Okay, dimension of linear momentum. Dimension of linear momentum, everyone knows m into v is the momentum. So v is the lt minus 1, mlt minus 1, not matching. Angular momentum is very, very clear to you. So mvr every, okay, means all three terms, you know, maybe angular impulse generally not used much. Used, of course, okay, that's why we have written. Angular momentum we use so many times in the modern physics in the your rotation. So m, and this is velocity is lt minus 1, and this r is l. So this is also matching. So your two options are matching. Maybe in the Neet they will change one of the option. Okay, in place of angular momentum they can write something else. Answer can become angular impulse. Possible? Can we do this one? Okay, so this will be there. Okay, you can check. Okay, file will be there. Okay, now comes question from the your okay, here 1 year calipers, screw gauge always important. Okay, and this is the question from exemplar only. Vernier scale of traveling microscope. Traveling microscope is the one experiment we have in our syllabus. Okay, in optics, one simple question is there on the traveling microscope. I will tell that. Okay, today. So traveling microscope, they are using the word here 50 division, which coincide with the 49 main scale division. If each main scale division is this, means this value is given as MSD. MSD is this 0.5. Calculate the minimum inaccuracy in the measurement of distance. Always remember, minimum inaccuracy is basically your least count only. Okay, least count. Okay, They are talking about the least count. That is the minimum count you can take. That is the, okay, your error also. Least count indicates error. So now we can see that here in this one, minimum, okay, they can say minimum accuracy or Vernier constant or least count. These are the three names, okay. Sometimes they will say Vernier constant. We are familiar with the least count word only, and they are using the minimum accuracy word. They are using the Vernier constant word. They are using the least, okay, least count everyone knows. Now we can say this formula is simply your MSD, least count is always equal to MSD minus VSD. Now you will say here, sir, in this one, here if you say okay, 50, if you say, okay, 1 year scale 50 VSD is equivalent to 49 MSD. This is the method, okay, to solve formula only MSD minus VSD. This is formula written 1 MSD minus 1 VSD. In this formula, MSD is given to you. This is the MSD given. You have to substitute VSD value, okay. VSD value you have to substitute. MSD given here, okay. So MSD given, of course, you will substitute the VSD because formula is MSD minus VSD, okay. So we can write in this one, 50 VSD is this one. So 1 VSD value that you have to substitute, it becomes 49 by 50 of MSD, okay. Then in this formula, MSD minus VSD, MSD is given to me in the question. I am going to replace this, okay, VSD. How to replace this VSD? As per the question, 50 VSD equal to 49 MSD. So 1 VSD will be 49 by 50 MSD. Now you can put here, so 49 by 50 MSD. And now this is MSD is given to you. If you solve 1 MSD minus 49 by 50 MSD, it becomes 1 by 50 MSD. And what are the MSD given? 0.5. You can see, okay, that, okay, it is given in the problem that 1 MSD is 0.5. So you can say, sir, 0.5 divided by 50. Okay, you can remove the decimal, it becomes 1 by 100, and 1 by 100 becomes 0.01 mm. So in this question, you got how to solve the questions of your least count Vernier calipers. Formula is simple, MSD minus, formula is simple, MSD minus VSD. MSD is mostly given to you. Most of the day MSD is given. And if MSD is given, you need to substitute VSD. And how you will substitute VSD from the relation given, they will give something like this. 50 division coincide. 50, okay, Vernier scale has 50 division, means 50th division, okay, 50th division of Vernier is coinciding with 49 main scale division. So 50 VSD equal to 49 MSD. So 1 VSD equal to 49 by MSD. And then we have substituted it there. We got this answer. Yes. This question is clear. Okay. Now, I have written here something extra because you people keep on doing these mistakes in the unit conversion. Like if kilometer to meter per second, you can multiply 5 by 18. Everyone knows, but it's still written here. Okay. Like 90 kilometer per hour. So 90 into 5 by 18 becomes 25 meter per second. Kilometer and meter. Okay. Kilometer per hour to meter per second. Kilometer to, okay, kilometer to meter per second, okay, you have to multiply by 5 by 18. Like if I say, suppose, okay, you will use like this 72 kilometer per hour, okay, you can say simply I will multiply with the 5 by 18. This becomes here your 4. Answer becomes how much? 20 meter per second. But in the kinematics, you have to use meter per second, okay, and they will give mostly in the kilometer per hour. So you will use this, okay. Remember this thing. Second one is the nanometer and angstrom mistakes. I have seen people keep on doing again and again. Like in the de Broglie chapter, chemistry also, in physics also. We remember all the formula in terms of angstrom, and they are giving us asking answer in the nanometer. So remember, 1 nanometer is basically equal to 10 angstrom. Okay, nanometer means 10 power minus 9. And 10 into 10 power minus 10, this also becomes 10 power minus 9, okay. And this is the third thing you do mistakes in the your KTG, mainly in the KTG, in the chemistry also, okay, KTG Thermodynamics chapter. 1 cc means there is the cubic centimeter, and this will be equal to 10 power minus 6 meter cube, okay. Yes, so these are the some mistakes, basic mistakes people do here, okay. Now, again, these questions are from the exemplar here, okay, for the practice taken. So, means how to check your correct answer, okay. Here a method is there, okay? Will not go by the method. Momentum, area and time are taken to be fundamental quantities. Then energy has the dimension formula of, okay? Now you know that best method is this, that you will write like this: energy proportional to P power A, है A power B, or okay, T power C, like this we do, okay? But I will say that you can go with the option checking and common sense here, okay? Because you know that momentum is simple m into v. Momentum is mv, okay? And they are asking about the energy. It means momentum is mv, you need one more v. You need simply what? One more v. It becomes mv square. Mv square is the energy. Mv square is having the same dimension as the energy. Half is the constant. So now we can say we need one more velocity. Now you will check here p square, no, because m square v square, okay? Then you have to check these options in which one you can easily get the velocity. This is the a minus t minus 1, area and t. It will not give you velocity. If you see na, area will be what? L minus 2, L minus 2t, not possible. This one, if you check here, then this will give you L, okay, minus 1 into t. It is the inverse of velocity, okay? But if you check this option, area power 1 by 2, area is the L square power 1 by 2, means this becomes L, and this is the t minus 1, and this is, okay, this is the your, okay, this thing I have written, and momentum is how much? Momentum already, you know, m v, okay? So mv into lt minus 1, and this mv will be how much? Again, okay? V is the LT minus 1, we can write, okay? Now you can say, yes, this is the formula of energy. Can you check the options like this? But because momentum is the mv, we need, okay, that other two terms should be equal to the velocity. That's it, okay? And here these two terms are equal to velocity. This is the option checking method. Option checking method is much better than the, okay, traditional solving. How you will solve traditionally, I will write here. Energy will write in this one, momentum power A, area power B, and time power C. I hope this method is clear to you, everyone. You will write dimension both side, and how to write dimension both side. You can write here ml2 t minus 2. This side you can write, okay, equal to momentum mlt minus 1 power A, okay, area L square power B, and this is the time t power C. You have to find the values of A, B, C by doing the comparison. It takes some time. Option checking does not take time. Of course, option checking you need some common sense, okay? That you will not check all the options. You are going to check, suppose, all the options. It will take there also time, okay? You can discard some of the options, okay? Then only option checking method is beneficial, okay? If you are not able to discard any of the option out of 4, it is better to solve. If you can discard 1 or 2 option, go with the option checking, okay? Remember this thing, when to go for the option checking, whenever you can discard 1 or 2 option. If you are not able to discard, go with your regular method, okay? Yes, and if this method is not clear to you, anyone, okay, if this method is not clear to you, you have to, okay, you can just discuss with your okay, respective teachers. All teachers are available in the different campuses, okay? You can take some time. It just takes 2-3 minutes. It will take. You can easily learn this method, okay? Option checking will be there, as well as this also will be there, okay? Now, then we have next one. This is the, okay, one more question I have written, okay? It is not exactly from the your okay, but based on the, okay, exemplar, okay, not exactly. Like sometimes they can give you this thing, okay, velocity equal to A plus BT plus CT square. You know that in this one, okay, those quantities can be added or subtracted which are having dimensions same. Means A will be equal to the velocity, BT also will be equal to velocity, okay? Velocity means what? LT minus 1, okay? And your CT square also will be equal to LT minus 1. They can ask sometimes dimensions of A, B, and C. I thought this question, okay, somewhat good. They may not ask only C. They can ask some relation between A, B, C. What are the dimension of A, B by C, like this, okay? So, you know, A is the LT minus 1. But B, if I check, then B, you will say this will go that side. So it become LT minus 2, and if C you are finding, then C will become LT minus 3, okay? But this is the LT minus 1, this is the T power 2, it will go this side, so LT minus 3. So this is the A, this is the B, this is the C. I have asked only C, but they may like this dimension of, they may, okay, change dimension of AB by C. Like this they can make the questions. Yes, it is okay? Clear? Okay, we'll go for the next questions. Means some are written whatever like this AB by C, okay, A square B by C, like this they can make the things. We'll go for the next one here. Because this chapter is having more weightage, that's why we are taking more time also. I have divided the time and slides depending on the weightage of chapter, like 3 questions. So almost, okay, I thought that I will go around 45 minutes for this chapter. And yes, 3-4 things are there in this one. This is the one question from the error, good question, and okay, it is the your NCERT based. In this one, this time if you see in the NCERT error part they have deleted, but error part was always important. Okay, that's why I have taken this question here, because some lot of things they have, okay, eliminated from the NCERT. These questions are the basic, like Z equal to, given here in this one, A square, okay, A square B by C cube. Whenever you get like this, always errors are always added. Even though this power is downside, it is negative, you will write like this. So delta Z by Z into 100 must be equal to here 2 delta A by A into 100, plus here we can write delta B by B into 100, plus I can write here 3 delta C by C into 100. Yes? And once you have written like this, anywhere any negative power is also there, you cannot write negative. You have to write as positive only, okay? You have to make it positive, okay? Now, so this becomes 2 delta A by A. In A, how much error is there? 1%, so we'll write as 1 here. In B, how much error is there? You can say 2. And in the C, how much error is there? There are the 3. Okay, like this we can put here, and now you can say yes, this is your answer. 2, 2, 4 and 4, 9, 13. I hope this type of pattern also we can do it. Possible? Okay, good. So now, okay, only data they can change, slightly equation they can change, pattern will remain same. Okay, again I am saying whatever question you will see in the examination, pattern will be same. Data may match, okay, because we have taken the similar from there, but patterns will not be out of this. Okay, now next, okay, I have taken this question. Okay, like as usual I make the questions. So Professor Cool claims he can measure the thickness of human hair using the screw gauge, because NCERT not written about the screw gauge. Okay, so taken this one, but based on the experiment only. Okay, they are saying least count is 0.01, okay, given here, and they are saying if the measurement is 49 mm with 3 division on the circular scale, language slightly twisted as they may twist. Okay, in this one 0.49 mm with the 3 division in the circular scale, reading they are asking, and you know reading formula is this. Okay, reading formula is main scale reading plus least count into circular scale reading minus 0 error if any. Okay, minus 0 error, we are not talking about 0 error. Okay, this is the formula of reading. Now problem is, in this question if you read 3-4 times, then only you will be able to figure out that okay, this 0.49 is the main scale reading. Okay, if the measurement is 0.49, it means this is the main scale reading and 3 divisions are the circular scale reading. So we'll put here 0.49 plus least count 0.01 into C. Okay, circular scale reading is 3. Okay, so 0.49 plus 0. Now calculation is very basic. Okay, you can just add here and okay, you got the answer 0.49 plus 0.03, which becomes 0.52 mm. Yes, clear here? Okay, here I will say one more extra things you will remember. Least count of screw gauge is equal to pitch divided by number of division. If they are asking the least count, pitch by number of division. Okay, pitch by number of division. Okay, because in the screw gauge they can only ask two things. Either they can ask least count, either they can ask question of reading. I have taken by slightly twisting this language with language. Okay, I'll see that people cannot easily that what is the MSR, what is the question will be basic one liner only, like here this is the simple one liner. MSR main scale reading plus LC into CSR, main scale reading 0.49 plus 0.01 into 3 0. Okay, this is the answer. And least count is nothing but the pitch by number of division. Okay, yes, any problem here? Okay, we'll go for the next one here. Now it's time to finish this chapter quickly. This chapter is over already. Okay. Now, if anything you want to ask, we have taken here question on the least count. What we have covered till now. Okay, quickly I will say. Okay, in this one that we have covered here screw gauge. Okay, screw gauge, and you will revise this. Okay, we have covered the vernier, we have covered the error part, we have covered significant figure. Okay, significant figure, and we have covered the dimensions. We have taken only those dimensions you can do direct plus or minus, which are dimensionally same. Okay, all important questions of the NCERT solved examples, exercise questions, and exemplar also covered. Yes, yes, you have to revise this thing. Okay, this slide. Okay, 2-3 times I will suggest at least you will revise. Okay, now comes next chapter is the gravitation, one important chapter and 2 questions. Okay, so first was the 3 questions. When 50 questions were there, unit dimension 4 questions they used to ask. Now I'm saying 3 and gravitation. Okay, this is the first example of the gravitation from the Kepler's law. Kepler's law, I hope everyone knows. Yes. First law is your law of orbit. Planet revolve in the elliptical orbit. Second one is saying about the area that okay, it says that the line joining sun and planet covers equal area in equal time. Line joining sun and planet covers equal area in equal time. And third law about the Kepler, quite famous one, T square proportional to R cube. I have taken okay, questions from each, which what means important questions here. Based on this, they have asked previously multiple times. They may repeat the same question. Let's read it here. They are saying in this one, let the speed of the planet at the perihelion, okay, be Vp, and sun planet distance be the Sp. Okay, listen, this point is known as, okay, here perihelion, and this one is known as aphelion. Okay, they are saying here speed is your Vp, and this speed is your okay, Va. Okay, and then they are asking in this one, relate Rp Vp to the corresponding values. Okay, quantities at the aphelion. You know that V is always proportional to 1 by R. Okay, this one you have to remember. Wherever distance is less, velocity is more. Remember, here distance is less, this velocity will be more. Here distance is more, velocity will be less. You can remember this way also. In the more funny way, if I say, you can remember that if you are close to sun, you will feel so much heat, you will be running faster away from sun. Means when you are closer to sun, you are going to be fast. Okay, this is the funny way only. Actually is okay, written here. This comes from the okay, angular momentum conservation. And you have to remember, angular momentum is conserved about sun. This line should be remembered. Angular momentum conserved about sun. A lot of people simply remember angular momentum is conserved, but they don't remember about which points. About sun, angular momentum is conserved. Now we can say V proportional to 1 by R. That's why it is written here that Vp by Va equal to Ra by Rp. Okay, this is the one. Okay, and written here, if you read this one, okay, that's why I have taken this snip here, that from the angular momentum conservation, this relation is coming from the angular momentum conservation, which is conserved about sun. Okay, so we can say V proportional to 1 by R, and this is the thing, and we know that here, okay, this Vp is greater than okay, Va. Okay, here velocity is more, here velocity is less. They have asked about the sometimes kinetic energy also, so we can say kinetic energy, okay, Ke at the P point will be greater than Ke at point A. Okay, if you remember, if you have solved the PYQ question, you will remember, yes, they have asked question for the this radius based also, kinetic energy based also they have asked, and previous okay, not recent year they have asked 3-4 years back, okay, to they have repeated this thing. Now this is the first question that is asked. What is the expected now? This question, second one, will the planet take equal time to traverse BAC and CAB? This one everyone knows about the velocity. They can give the distance also, like this is the R, this is the 2R, then what is the ratio of velocity? You can find the ratio of velocity. Second question they have not asked. We have asked multiple time in our examination. Okay, you will remember. You will see in the notes also that will the planet take equal times to traverse BAC and CPB? I will take different color here. What is the meaning of BAC? Means this is the BAC. Okay, means here to here. Okay, this green, okay, line. Okay, they are saying in the green as well as in this okay, this side I can take the yellow one. Okay, CPB. So green and yellow time are going to be same or different, you have to say. Okay, green and yellow. Okay, because if you say this length is same, half this side, half this side, what you say, time is same? No, time is not same, because you are not considering the length here. You have to consider area in this one, and this green side area is more. Okay, you can see, because always line joining sun and planet, this side this much area is there, and if this side this much area is there, area is more, that's why this time will be more. Here time is supposed T1, here time is your T2. Okay, then you can say always, okay, this time is okay, less. Why time is less? Because area is less. They can make here your assertion region type question also, statement question also. So always remember this one, that yes, here to here, if it is covering, okay, even though this distance is half, time is going to be more, because area is more. Correct region will be area is more. Okay, correct region is area is more. And here this okay, length is same but area is less. Okay, you will see here. Okay, region is written here. Okay, so I will go for the next one. Okay, how explained. Okay, you will see that area SBAC bounded by the ellipse and radius vector. Okay, SB and SC is larger than the SBC. From the Kepler's we know equal area and equal time, hence the planet will be taking the longer time. Okay, traverse BAC. Okay, in the BAC it will take more time. Okay, and you will read it again. Okay, now coming this question from the your okay, again solved example, and here I have not taken the okay, solution of this. So this solution you can write, actually NCERT solution they have written very complex way. So if any complex solution is there, I have not taken. Okay, otherwise you might be confused, because sometimes questions are much easier. NCERT makes complicated, and then people say that NCERT is tough. Three equal masses are kept at the vertices of a equilateral triangle. I will draw here. Okay, three vertices. Okay, like this I will draw. Okay, and they are saying in this one, okay, equilateral triangle, this is the M, this is the M, and this is also M. Okay, see this one clearly, and you can write three equal masses of mkg are fixed at the vertices of equilateral triangle ABC. Okay, first one they are saying, what is the force acting on mass 2m placed at the centroid? Here we are keeping the 2m. They are asking force on this. Okay, now you have full idea. This will say this say to this mass, okay, come this side, this will say come, okay, this side, this will say come this side, and you know all these forces are okay, equal in magnitude. So resultant is going to be what? 0. Okay, like okay, you have seen the in the Lamy theorem or any of the things you can use. We have used this vector addition so many times. You know the method, you don't know the method, but feeling is coming. Yes, answer is 0. Okay, I'm 100% sure. Those who are listening this thing, they know yes, answer is 0. One pulling this side, one pulling this side, one pulling this side means it is 0 because equivalent magnitudes we can say here. This F net in this case becomes 0. Okay, which is the quite simple case. Now number B. Okay, B is saying here in this one, if you say, what is the force if mass at the vertex A doubled? Now this becomes slightly technical question here. Okay, we can say that earlier here M, and here also M, but now they are saying that here double. Double means what? I am keeping the mass M. One more mass I am keeping M here. Then only it will be doubled. So we can say M was there. Now we are doubling. Doubling means we are keeping one more mass here, which is the M. Okay. Now then we can say this is same is still 2M. Okay. If you remember, multiple times we have discussed this thing. Okay, that if this will be having here, okay, F, this will be having F, and this will be also having F. This, okay, these three F will be cancelled or not cancelled? You can see yes, because this M is pulling it up, this okay, pulling it right, this is pulling left side. You can see yes, these are going to be cancelled. And if these are cancelled, then which is left? Which one will be left? You can say only one will be left, only this will be left. So effectively, if I say, you have to only consider force between, okay, this 2M and this M. That's it. Okay, this one you have to consider here. Okay, so you can say this force, if I have to write, then it becomes a 2, okay, G M square divided by, okay, this distance. Clear? Okay. Yes, now you will see that solved example, okay, because I have not taken here in this one that solution because they were writing very complicated way. So if all are equal, it will become 0. Okay, it will become full 0. And if they are saying here we are doubling, then also we can say this M and this M, this M will be 0. Only what will be left? 2M and M will be left. So this becomes F equal to 2gm square by R. Clear? Concept is clear? Okay. Means in this one, this is the one trick point here, that if they are saying here double, so M is still cancel. Okay, this M resultant of this M cancel, only one M will be left here. Now I will go for the next one. Okay, this is the exercise question from the gravitation taken in this one, because in the solved examples are lesser here. So they are saying a body, because I have to cover all the topics also. So there was no solved example in the variation due to height and depth. Okay, you know that variation of G with the height, which is always important, formula is given by this: G divided by 1 plus H by R whole square. Okay, they are asking that body weight 63 Newton on the surface of Earth. It is the 15th question from the exercise. Okay, from chapter 7, means gravitation. At the surface of Earth, 63 Newton. They're asking what is the gravitational force on it, okay, due to Earth at the, okay, what height? Height equal to half of the radius, means H is given here in this one, that half of the radius means R by 2. They're talking about the weight, so I can multiply here M and here also M. So I will get the weight directly. Let's put the data here. Mg is given 63 at the surface of Earth, divided by 1 plus H is given R by 2 into R whole square. R you will cancel. So this one becomes 63 divided by 1 plus 1 by 2, which is the 3 by 2 whole square. And now I hope you can calculate this thing. 63 divided by 3 square is 9. 2 will be off. Yes? Over? Can we do it? Formula you have to remember. And then, okay, basic question. Maybe slightly language they may change, or they can keep as it is. Okay, this is the one question for height. Yes, moving forward. Yes, then in this next question I have taken that there were the 15 and the 16. Both questions are always important whenever they have to ask the questions from the variation of G. These are the two same questions they will take. They are saying assume Earth to be a sphere of uniform mass density. how much would a body weigh down to the center of Earth? Okay. Now, halfway down they are asking, means if I take this is the Earth here, okay, they are asking in this one, this is the center. They are not asking here, they are asking at this depth. You know, sir, here at this point they are asking here depth will be equal to R by 2, and you people have to remember this formula, okay. Sometimes where solution is not there, you can note down those things, okay. When this slide will be there, you can easily match. Now we can write here with the depth G formula, GD is always equal to G 1 minus D by R, okay. G1 minus D by R. We need to find the weight. So here M and here also M. So mg in this case is how much here? Your 250, and here we can write 1 minus D. D is how much here? Your R by 2, and R will be cancelled. 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. 250 into 1 by 2, 125. Yes? Can we do these two questions from the variation of G? A solved example not given on this one, so take in question from exercise. Okay. Yes. Clear? Done this one. Now I will take the next one. Okay, so let's go for the next. We are going to almost 2 hours will be over. Not 2 hours. Okay, we have a lot of time. Okay, design in such a way so that all the things will be covered. I took a lot of time to think which questions to take, which not to take. Okay, which will be more relevant, which will not be relevant for this year, because each year we change the things. Now, so next one is taken. This is the exemplar question. I thought this question to be very, very good. Okay. Okay, so from the NCERT it is there. Okay. Very simple question. Maybe I'm feeling that they can ask this one. You see this one, okay? First, then I will explain. Okay. First, you see this one. 2M and M are respectively at the point. Because this question till now we have not asked. Means I was thinking that how this question left, we didn't ask in any of the examination. Mostly I try to include questions from the NCERT exemplar, all okay, but not asked till now this one. Particle of mass 2m, m and m are respectively at points A, B and C. They are saying AB is half of BC. We say BC, okay, if AB you take x, this one is the 2x, that is the okay? AB equal to half of BC, and mass is very, very small as compared to this capital. And time t equal to 0, they all are at rest at subsequent times before any collision takes place. So light is also very beautiful here. They will try to confuse how collision words is there, t equal to 0 is there, it means okay, we have to think too much. Nothing, you have to think very simple. They are asking where this ion will move. You know, ion will move that side where force is more. Oh, this mic. Yes. Oh. Okay. This mic is, I think, before my class, AKD class was there, no? So I think with the energy he thrown the mic, so this mic is disturbed. Now okay? Yes? Okay, good. So what I'm saying here in this one, this will move only that side where force this, okay? So this 2m will say this mass come this side, okay? F1, and this will say come this side, and this will be the F2. We have to find F1 and F2, then we can decide which side it will move. So you can say, sir, F1, if I write now, F1 will be simply equal to G into 2m into m divided by x square. If I say F2, then F2 you can say, okay, here will be G into m divided by 4x square. I hope clearly you can see which force is more, F1 or F2. Which one is more? You can say this is not a tough question. Appears like very tough question because collision word and this AB equal to half BC, you might think it is the mathematical question, but now you can clearly see that in this one F1 is more na. You see here F1 is greater than F2, and if F1 is greater than F2, then okay, which side it will move? You can say it will move towards 2m. Tick. Okay, done. And sometimes when I feel that yes, this question will be asked, that question is generally there in the examination. Okay, yes. Okay, clear this one? If they are asking a net force also you can write. Okay, net force will be equal to how much? F1 minus F2 will be the net force. Okay, add okay, removing this one. Okay, explain. Change. Good. Simple question, good question. Actually, I liked this question. Okay, very much. Why I don't know. Okay, sometimes when okay, some feeling is coming. Okay, yes, you know, intuitions are coming that this question is going to come. Maybe they will copy or they will just change some data and then okay, net force they can ask. Now, this is the one question here. They're asking find the potential energy of system of 4 particles placed. Yes, F net you can find 7 by 8. Yes. A square is there. Okay, this is the NCRT solved example. Okay, you people have solved the exemplar. I don't think that okay, because only on online people can answer. I said so many times we have to solve exemplar we have to solve. I don't think by this time also people have solved the exemplar. Right? But no problem. Okay, at least important questions will be covered from there. All not possible. Listen, this is the square. So we can say, okay, potential energy of the system of 4 particles placed at the vertices. These are the M here, okay. And then they are asking what are the potential energy. Now you know that in this one, how many for the potential energy you need to find the interaction here. Important question. See this one, okay. Sometimes we ignore some solved examples and quite good question. One interaction here, one interaction here, one interaction here, one interaction here. These are the 4 interactions which are having the okay separation as A. So we can write this will be equal to potential energy. They are writing W, I can write whatever, okay, your wish. So we can say this one will be equal to here minus 4 gm square by L. These are the 4 interactions along the side which has what? Side L. But you will say some other 2 interaction also there, okay, in this one. This is the one interaction and this is the one interaction. Here also interaction is there. Can you see this one? And these interactions are having 2 interactions are there along the diagonal interaction. In these diagonal interaction, okay, 2 diagonal interaction having the length how much? Root 2L. So I can say minus 2 gm square divided by root 2L. Okay, this is the thing. Okay, and this is the answer. That's it. Okay, any problem in this question? I will spend some time with this question because I know people ignore this question. They don't do, they think that this cannot be asked, but good question because only one line is there. 4 interactions are along the side, okay? Side length is L here, okay? Like this. So we can say 4 interactions, 1, 2, 3, 4. So 4 gm square by L written. 2 interactions are along the diagonal. These diagonal length everyone knows that is the root 2L. So 2 gm square by root 2L. That is the total answer for this one. Okay. Then here they are asking second part, and second part is also important. Both parts. Now, and second part is much more important than the first part. Sometimes people do the first part, second they ignore 100%. So they solve up to this, then okay, they finish the question over. Now we'll go for the second. In the second, they are asking find potential at the center of a square. Okay. Generally what people do mistakes, they say, okay, we got the potential energy, we'll divide the mass, it becomes the potential. Okay, like this is the potential energy na, in the potential energy divide with the mass, you get the potential. Not correct. They are asking potential at the center of a square. You can say at the center of a square. I will draw another diagram here for this one, for the second, like this. So here potential will be because of each mass. This will have potential, this will have potential, this will have potential, this will have potential. So all four will have potential. So we can say because of that potential becomes here in this one, okay, potential equal to minus 4 gm, okay, potential because of this one gm divided by this distance r, okay. This is the value, minus 4 gm by r, okay. But you will say, sir, what will be the r here? This total, okay, total age, okay, this total is how much? Root 2l. So total you will say, sir, 2r is basically equal to root 2l. So r will be equal to how much here? Your l by root 2 you will put there. So minus, it becomes here, okay, minus 4 gm divided by r, which is the l, by root 2. It will be here. That is the answer. Okay, see this question. I am okay taking some time in this question because I feel maybe, okay, this potential question, okay, not the potential energy, but this potential question is really important here. That yes, this is the m. So we can say minus 4 gm by r. So minus 4 gm, r will be l by root 2. Okay, total is the diagonal, which is the root 2l. Half of that will be root 2. Okay, half of that will be root 2 l by 2, which becomes l by root 2. Clear? Now I'm going for the next one. Okay, select escape velocity, because they have not given much details in the escape velocity, only formula type things they have written. And so I added this slide here. Okay, you have to remember for the escape velocity, this is the formula. Escape velocity equal to root of 2 gm by r equal to root of 2gr, okay, equal to root of, okay, here in this one, okay, 2g by r, and mass you can write volume into density. So 4 by 3 pi r cube rho, if you put, then it becomes, okay, because maybe you will not remember, that's why I'm writing this way. So 8 by 3 pi r square g. These three formula must be remembered by everyone in the escape velocity. If mass constant, then v proportional to 1 by root r. If g constant, okay, then we can say v proportional to root r. And if density constant, here density also there, okay, if density constant, then v proportional to r. Okay, three formula, okay, and these three relation, some good questions are asked on these ratio based questions on these three relation, and people don't remember exactly which one to use. Okay, now let's see the questions here. Escape velocity is independent of, you can say yes, mass of the planet, it depends. Radius of the planet depends. Gravitational constant, it depends. It will not depend on the mass of object. Independent of mass of object. Okay, it is independent of mass of object. Okay, means if I throw 1 kg, 2 kg, 10 kg, 100 kg from the surface of Earth, escape velocity from the surface of Earth is going to be 11.2 kilometer per hour. Okay, yes, this one is clear. This covers theoretical aspect of the escape velocity. It does not depend on the angle of projection also. Okay, at what angle you project does not matter, it will remain same. Okay, now this is the one question, good question. If the radius of Earth suddenly becomes 4 times larger, radius becomes 4 times and mass remains same. Okay, now this is the condition given, mass remains same, because if they say that small g remains same, density remains same, then okay, answer will be different in the different variations are there for the V. They are saying mass remains same, okay, and 4 times, okay. Now you can clearly see that if mass remains same, I will use this relation, V proportional to 1 by root R. R becomes 4 times, velocity will become what? Velocity becomes half. Velocity becomes half, because we are going to use this relation, V proportional to 1 by root R. R becomes 4 times, that's why velocity becomes what? Half. Clear? But you have to find that point, okay, that whatever the point is given here, that point you need to figure out, okay, what is constant here. Clear? Okay. Now I did some more question on this also, density also in the next slide, okay, that density will be constant, then you will take V proportional to R, okay. So I cannot save this thing. You can either write this, whatever I'm saying, okay, you can write better, and when this slide will be there, you will, okay, take along with this thing. Now, they are saying this one good question, theoretical one. Object is projected with escape velocity from Earth, ignoring air resistance. Its total mechanical energy infinite distance from Earth is. Okay, I have taken this question from the exemplar based. Actually, in the exemplar, 3 options were there, so I made it as a single option type. You have to, because I have to say some things here in this one. Listen. Number 1 is velocity of projection is velocity less than velocity of escape. Number 2 is velocity of projection is equal to velocity of escape. Very important cases. Velocity of projection is more than velocity of escape. Okay. Remember all 3 cases. Multiple times they have asked. So if velocity of projection is less than escape, okay, particle will not reach infinity. Particle will not reach infinity. Okay, will not reach. Okay, will not reach infinity. It will reach some maximum height, and maximum height is given by k square by 1 minus k square into R. Okay, you can say, sir, what is the k here? Okay, I'm saying a Vp equal to, okay, Vp equal to when k times of V, where k is less than 1. Okay, k is less than 1. Okay, if k is less than 1, then what will happen? Basically, it cannot reach infinity, and it will reach some maximum height given by this formula, k square R by 1 minus k square, and its total energy will be negative. Total energy negative means it will be bounded. It will be bounded means, okay, falls back, and falls back. Okay, you have to remember its total energy still will be negative. You have not given more energy, so total energy will be negative, and it will remain bounded. Whenever total energy is negative, it will be bounded system. Okay, and it will fall back if you are given lesser. Okay, here we are saying Vp equal to V. Okay, Ve. Okay, particle, okay, reaches infinity. Particle reach infinity. Okay, particle will reach infinity. Okay, velocity at the infinity will become 0, means no energy will be left. Okay, here total energy becomes 0. In this case, total energy is 0. Okay, if you project any particle with the equal to V escape, particle will go to the infinity, but its total energy is 0, and on reaching infinity, it don't have any velocity left. You have to write these points. Okay, because space they are not there in the NCERT, but they have asked multiple times. Okay, that's why I have taken this question and writing here. Okay, so note down this thing. Vp greater than Ve. It means Vp is basically equal to k times of Ve, but here k is greater than 1. And if k is greater than 1, particle will reach infinity. Okay, particle, okay, because you have given so much energy, particle will reach, okay, infinity, and V infinity will be equal to root of k square minus 1, root of k square minus 1 into Ve. This velocity also particle, okay, will be left. Particle will reach infinity, and this much velocity also will be left with the particle. V infinity will be root of k square minus 1 into Ve. Okay, yes. Now, here in this case, total energy of the particle will be positive. Okay, so these are the three questions if they want to ask about the total energy. In which case it is the positive, in which case it is the negative, in which case it is the zero. So you know that if you are giving the velocity lesser than escape, it means you are giving lesser energy than the required energy, escape energy. In that case, your total energy will remain negative. It will be bounded. It will be falling back to the earth, but it will reach some maximum height. Okay, before falling, it will reach some maximum height, and that maximum height is given by k square r by 1 minus k square. And then we can say here in this one velocity of where k will be always less than 1. If you are giving equal, if we are giving equal, then particle will just reach the infinity, just reaching the infinity. On reaching infinity, no velocity left, no velocity left, and total energy will become just zero. Total energy is zero. Okay, and if you are giving more energy, like this is the third case, Vp greater than V, Vp equal to k times of V, where k is greater than 1, particle will reach infinity, and on reaching infinity, okay, it will be having this much velocity left and total energy will be positive. Okay, so remember, total, if they say that total energy of the particle is positive, it means it is projected with the more than v escape. Zero projected with the v escape, negative less than v escape. Clear? This is the question written here. Object is projected with the escape velocity from the earth, ignoring this one, its total mechanical energy at the infinite distance. You can say 100%, this is the zero. Why zero? Because with the v escape we have projected. Greater than v escape positive, less than v escape negative. Okay, you can take the picture if you want. Okay, yes, I will erase this. Now, this is the next question from here. If a planet of same density, I just said that I will use the same density. You know, for the same density, V proportional to what? R. Okay, they are saying, but twice the radius. If twice the radius, then escape velocity would be, you can say radius double, escape velocity also double. Okay, if they are saying for a planet of same density as Earth, but twice the radius, we can say if radius double, your escape velocity will double, because this is the relation V proportional to R. Okay, so remember, three relations are there with the radius. It is the R also, it is the root R also, it is the 1 by root R also. Which one you have to use wisely. Now, coming this question from the NCERT solved example again. Planet Mars has two moons, like we have one moon. Mars is having two moons, Phobos and Deimos. Phobos has period of 7 hours 39 minutes and orbital radius of this. Calculate the mass of Mars. When this question they will ask in Neet, probably they will change the data, because this data is very, very calculative. They will make somewhat simple data. But you cannot expect, okay, maybe they are lazy a little bit, they can keep the same data, you have to do it. Okay, so here calculation is there. I have taken this question so that you will remember this formula. Okay, this formula is T square equal to 4 pi square by gm into r cube. It is actually from third law, T square proportional to r cube. Everyone knows T square proportional to R cube, but full formula we are not having in the memory. This is the full formula you have to remember. T square, okay, is equal to 4 pi square, okay, 4 pi square by gm into R cube. And remember, this m is the mass of central body. Okay, m is mass, not mass of revolving body, mass of the center body. Okay, m is the mass of center body, not the revolving body. M is the mass of center body, not the revolving body. Clear? Okay, m will be the mass of center body, not the revolving body. This formula we know, all we know. Okay, this one you remember, 4 pi square by gm. M is the mass of, okay, center body. Okay, so you will put the data here, you will get this thing. Data is quite calculative, so I'm not explaining this thing here. Then they are asking second one. Okay, second also they will change the data. That assume the Earth and Mars move in the circular orbit around the Sun, with the Martian orbit being 1.52 times. Okay, then what are the length of Martian years in days? we have to use this formula. This formula nothing but this one only. Here I am writing that one. T1 by T2 equal to R1 by R2 power 3 by 2. You will see in the notes, we have solved this question by taking 2 times, 4 times and 8 times. Okay, so T1 by T2, T1 is given, T2 is asked. Okay, they are talking about T2. T2 is asked. Okay, R1, R2 also given. Okay, relation is given for the R1, R2. So if we have to find the T2, I will simplify here. Okay, let me do it. So T2 will be equal to in this one, or I can write T1. Okay, T1, which is the T1 by T2 equal to, if you see here, Earth and Mars move in the Martian orbit is 1.52 times of the Earth. Means R1, if I take 1.52 R is for radius, R is for radius, okay, or I can write means R for the Earth and 1.52 for the Mars, power 3 by 2. Okay, power 3 by 2, and T1 value I have to put for the Earth. So for the Earth, this value is 365 divided by T2. Calculation, they will give simple RR, you can cancel, and this one will be multiplied. EG data they will give here. Okay, here data is slightly complicated, so you may feel question is tough. Question is not tough. You have number 2 formula. One is the T square equal to 4 pi square by gm. M is the mass of central body here, and then T1 by T2 equal to R1 by R2 power 3 by 2. Yes, clear? Okay. Data probably will be changed. Okay. Then taking this paragraph only, direct paragraph I have taken. So you have to read here that the kinetic energy of the satellite is given by this formula. Okay, half mv square, and then gmm. This formula in the short, actually I can write like this also: gmm divided by 2r. Okay, with the positive value. This potential energy becomes maybe around 10. I will take break. Okay, after completing 3-4 chapters. Yes, now, so this one is clear. Important question. Okay, now then these questions again from the exemplar it is taking, and this is a very good question. Actually, I liked this one because it is not stuck for a long time, sir. There is some network issues, so glitches. Okay, no problem. Somewhat we can manage. Okay, but we have to go. Okay, now we are almost closing. 3 hours will be done. Now, this is a very good question. Okay, because when I see again, why I have taken because we have not given this question earlier. Acceleration due to gravity decreases with the increasing altitude, correct? Because you know gh equal to g divided by 1 plus h by r whole square. Okay, so this option is correct. Acceleration due to gravity increases with the increasing depth. This is one is wrong, because you know gd is what? G1 minus d by r. This one is wrong. Okay, not correct. It will decrease. Okay, they are saying it is increasing, it is actually decreasing. Okay, D option they are giving here: acceleration due to gravity is independent of the mass of Earth. Okay, you know acceleration due to gravity is simply gm by r square. So this is also not correct. Now C option is the I like this question. I have taken this especially for the C option. Okay, from energy of orbiting satellite, repeat once. Okay, I will repeat the previous question, but see this one first of all. Okay, this one is especially taken for the C option, because everyone knows about A, everyone knows about B, everyone knows for the D. Acceleration due to gravity increases with increasing latitude. Okay, now what are the effect of latitude? Okay, whenever this is your Earth here, we know this is the your equator, this is the pole, and this angle is known as angle of latitude. Okay, so at the equator, if I say at equator, this latitude angle is 0. At pole, this angle is 90. And with this angle variation in the G, with this angle variation in the G is given by this formula, G minus R omega square cos square lambda. Maybe they may not ask numerical question, but they have given very good theoretical question in the exemplar. So G minus R omega square cos square lambda is the formula because of the rotation of Earth. You know now, as lambda increases, okay, this R omega square, okay, cos lambda increases, cos lambda decreases because cos is the opposite function, and if cos lambda decreases, this whole term, okay, will decrease. So you can say here in this one, what will happen? Your okay, G dash will increase. Okay, this one is there. Okay, see again this one with the latitude. This is the formula, G dash equal to G minus R omega square cos square lambda here. As lambda will increase, okay, why this formula question becomes, this line becomes very important, because a lot of people don't know this relation, that as lambda increases, cos lambda will decrease. In the cos 0 is the max, cos, okay, 0 max, and cos 90 is less. So we can write here lambda will be more, cos lambda will be less. Okay, lambda more, cos lambda less. So this whole term will be keep on decreasing. That's why G effective will be increasing. I hope this is clear. Yes. Any problem in this? Okay. So remember, you can take the screenshot of this one, okay, and C option especially here, okay. Yes, select. I am going to, okay. Previous question. Yes, in the previous question they were asking that how much energy you need to transfer it to, okay, from this orbit, like this is the, okay, your okay, Earth. It is moving in this okay, orbit right now, in the orbit of 2R, and then you are sending it to orbit of 4R here. Okay, so you can say in this one it will be equal to energy, means work equal to energy final minus energy initial. Energy final I can write here in this one, okay, formula is minus GMM divided by 2 into radius. What are the radius here? Your 4R, and here we can write minus minus plus GMM divided by 2, and what are the radius here? 2R. Okay, this is the, okay, calculation you have to do. Easy calculation, but question important. Yes. Can I move further? See, 25 pages we have done, 130 pages are there. By this time, 40 pages should be over. Add. But no problem, we are not worried about this one. So this also done. Now, this is the one good question taken, okay, I think from the exercise. This question is there, okay. In the exercise, 32 question, maybe exemplar, I think, in the exemplar. Object of mass is reached from the surface of Earth to a height equal to radius of Earth, okay. This is the, your some mass here, okay, mass M at the surface of Earth, and you are taking this mass, okay, to the, okay, that is taken from a mass is reached from the surface of Earth to a height equal to radius of Earth. Okay, that is taken from a distance R to 2R from the center. Okay, right now from the center. Okay, now if you see this question, they are trying to okay, specify more specifics of the question given. Sometimes they will give more detail of the question, and more detail of the question might confuse you. If simply they say that we are ranging from the surface of Earth to height h equal to R, question becomes very simple. But what they are saying, object of mass M is reached from the surface of Earth to a height equal to radius of Earth. Question phrased. Up to this question, okay, mistakes will not happen. But what is, okay, that is, okay, they have over specified, over explained this question. That is means taken from the distance R to distance 2R from the center of Earth. What is the gain in the potential energy? Over specifying any question makes slightly complication. Okay, complicated. You can say, sir, in this one, potential energy change, we have to find change in the potential energy will be equal to potential energy final minus potential energy initial. Potential energy final minus GMM divided by, we have to write the R, which is the final R is the 2R. Okay, is the total change same as change in the kinetic energy. If they are asking energy required, you will take the, okay, you will take total change in the energy. Okay, total change in the energy. Okay, that is same, only negative positive difference is there. Okay, kinetic energy positive, total energy negative. Okay, clear? But if they are asking a work required to, you will take the total energy formula, okay, to avoid any mistake. So GMM by 2R, okay, that is the here, okay, and plus we can write here minus minus plus GMM divided by R, okay, and you can say here your 2, here your 2. So answer becomes in this one GMM divided by your 2R. Yes, clear? Sometimes we write like this also, that Gm by R square in the small g. So in place of this one, we can write here, okay, Gm by R, okay, Gr equal to your Gm by R. So in place of Gm by R, you can write like mg R by 2. Okay, so maybe option they can give either this one, either this form. Okay, small g are replaced, means are replaced the capital G in terms of a small g. Okay, using the same formula, G equal to Gm by R square. I hope clear. Yes. Now I will move further. Yes. Okay, so we have done here two type of questions, in which one time we are moving the particle, and whenever they are moving the satellite, remember, if they are moving the satellite, okay, if they are moving the satellite, you have to take, okay, they are changing the orbit of the satellite, you have to take total energy only. Okay, because all the time satellite is the moving body, total energy should be considered. Okay, in that case, work done equal to total energy final minus total energy initial. Okay, yes. Now, so what we have discussed here in this chapter, first we got about the Kepler's law. In this one, gravitation is getting over here. Kepler's law. We did a question on the force, one triangle. We did the potential energy, variation with the height, variation with the depth, and in one question I have taken variation with the latitude. Okay, special variation with the latitude, maybe you have done or not done. Then we have done your in the satellite energy of the satellite graphs ratio and shifting of the satellite from one orbit to other orbit and shifting of the particle. This is the one thing. And in the escape velocity, three important conditions we have taken along with some questions. Okay. Now coming here, your mechanical properties of solid, very easy chapter and one question. Okay, we will quickly finish this one. Okay, because now in this one, some people have always doubt about this graph. Okay, and graph is very, very important. That's why I have taken this full graph here, so that at the, okay, at least one last time you can see this one here. Listen, in this one, what is there? Okay, the region A to B is known. Okay, in this one, if you see, okay, O to A, this is known as your okay, propose. Okay, here your Hooke's law is valid because stress is directly proportional to strain. Okay, directly proportional to strain in this one. Okay, so in this one, Hooke's law is valid, means O to A, your Hooke's law. Okay, what the Hooke's law? Stress proportional to strain is valid. Okay, stress is directly proportional to strain up to this point. If you cross this point AB, okay, up to A is known as your proportional limit. Proportional limit means stress is directly proportional to strain, and up to this only Hooke's law is valid. Remember this one. Okay, okay, remember this. Stress is directly proportional to strain. Okay, and up to this, okay, this relation is valid. A to B, if you go little, okay, then what happens? Hooke's law not valid. Okay, means A to B, okay, Hooke's law not valid. Okay, but it can regain, it can regain. Okay, it can regain. So this is known as your elastic limit. Okay, known as elastic limit. From A to B, Hooke's law not valid, but it can regain, it can come back. Okay, so known as elastic limit. Okay, that's why written here in the region from A to B, stress strain are not proportional. Okay, body still returns to the original dimension when the load is removed. Okay, the point B in the curve is known as yield point, also known as elastic limit, and corresponding stress is known as yield strength of the material. I hope this paragraph is clear to everyone here. This paragraph, okay, that A to B Hooke's law means O2 starting to A Hooke's law valid, but if you cross the A point, A to B, your Hooke's law not valid because graph is non-linear, okay, but it can regain. And if it can regain, then we can say this is known as your elastic limit or yield, okay, and yield limit or yield point you can say, and that stress, corresponding stress is known as your yield strength of the material. Then they are saying if you increase the load further, stress developed exceeds the yield strength and strain increases rapidly even for a small change. Okay. Now, then what happens that here becomes your point D. Okay. And this point D is known as ultimate. Okay. Point D, I will just erase this one. Point D is the maximum you can okay apply here. Okay, so read here that okay, the deformation is said to be the plastic deformation. Point D on the graph is the ultimate strength. This one everyone have to remember that this point D in the graph. Okay, this is point D here, and this one is the proportional limit. B is the yield limit, and we can say D. Okay, here this D is known as your ultimate tensile strength. Ultimate strength, more than this you cannot give. Maximum is the D. Okay, more than D not possible. Okay, if you apply more than D it will break. Okay, so that is written here that ultimate strength, point D indicates ultimate strength of the material. Beyond this point, additional strain is produced even by the reduced applied force, and fracture occurs at the point E. If the ultimate strength and fracture point D and E means this one, D and E, if very, very close, means it will break suddenly, that is the brittle. And if this is very, very large, then it is the ductile. Is this D to E they are saying, okay? Like I can say this one is there, okay? A, this is the B, this is the Z, and then here D. Means if D is E, and in the other one I can say like this, and like this is the D and this is the E. If D and E is very, very large, then we can say this one is the ductile, and D and E are very, very close. This one is known as brittle. Okay, so this one you have to remember here. Okay, and remember in this one, this slope represents Young modulus. Okay, this slope is always equal to tan theta, which is the Young's modulus. Okay, slope represents Young modulus. These are the some points you have to remember from the graph. D ultimate point, maximum point. Okay, more than this you cannot give. D and E very, very close, that is the brittle. D and E far, that is the ductile here. Slope represents Young's modulus in this graph. Okay, yes, this is the one special graph for the elastomers you have to keep in the mind. Okay, that stress and strain for the elastic tissue of aorta. Okay, you have heard so many times, tissue of aorta. Okay, and large tube vessel carrying blood from the heart. Okay, tissue of aorta, they don't follow Hooke's law, they follow non-linear graph. These are known as elastomer. Okay, so if they are asking graph for the elastomers, okay, elastomers does not follow Hooke's law. Okay, does not follow Hooke's law. Example is written here, that are the tissue of aorta, they don't follow Hooke's law. Okay, remember this graph also very important. Example also very important, that is the tissue of aorta here. Okay, okay, and these materials are known as elastomers. Okay, now this is the one question here. Again, calculation, okay, not much relevant here. They will change the calculation. Either they will give the easier data here. They are saying is a steel rod has the radius is given, okay? So, and length of this, along the length, like we can say this is the your string here, okay, rod, and they are saying in this one we are applying this 100 kilonewton, okay, force, and they have given the radius is 10 mm and your length is 1 meter. They're asking stress. You know, stress is nothing but the force divided by area. Force is 100 into 10 power 3 divided by area will be pi r square, okay, that they have calculated here, okay. I'm not going into the calculation. You can see I'm explaining the steps. Stress we got, okay. Once you got stress equal to force by area means 100 into 10 power 3 by pi r square, then they're asking how much elongation will be there, okay. For the elongation, you can use this formula directly also, equal to FL by AY. And I will say that you have to remember this formula. Anytime, okay, this formula will be used. Elongation will be equal to FL by AY, okay. Elongation formula, because maybe this formula only will be used, elongation FL by AY, okay. If they are asking finally strain, then you can say strain will be nothing but the your E by L or delta L by L, because elongation divided by initial length, that is the strain. So main formula is here FL by AY. In this one you have to put all the data, Young modulus given, area you have to find. Can you calculate this one? This is clear. Elongation FL by AY, okay, and strain equal to we can see by L. Yes. Add. Okay. And this formula E equal to FL by AY is always important, okay. Now, in this one, I have not taken, solution of this one, because this question is important, pattern is important, okay, not that, okay, whatever the solution they have given. Copper wire and the steel wire, okay, like this, are connected end to end. This is the copper wire, this is the steel wire, okay. They are saying in this one that a wire of length 1.6 meter, both of diameter. This diameter is your 3 mm and this diameter is also 3 mm, okay. Both diameters are same. Are stitched by here some force is that force is your F. The net elongation is given here, total elongation. You know, total elongation will be always given by E1 plus E2. So we can say total elongation E1 will be equal to F L1 divided by AY1 plus F L2 divided by AY2, okay. Using this, okay, can you find F? Can you find F? What they are asking in this question, find F, obtain the load applied. Possible? Because data, okay, Young modulus are not taken, whatever the Young modulus are there. Pattern is this, pattern is important. Total elongation is given. So we said total elongation is always equal to E1 plus E2. E1 will be FL1 by AY1 and this will be what? FL2 by AY2. In this one, your length is given. We can take here elongation, total elongation in this one is what here? 0.7. So 0.7 into 10 power minus 3. F I can take outside. L1 is your given 2.2 divided by AY1, because I don't know what are the, okay, Young modulus. They will give always, okay. And then we correct here, this is the 1.6 divided by AY2. And then you have to put the data. Easy calculation, important pattern. Yes? Clear? I will go for the next one. Now, a square slab of, okay, side, okay, in this one they have given. This is the your okay, side is given here, and then we are, okay, applying this force here. You know, because of this force, what will happen, that this will be having slightly displaced like this, and they are asking how much this upper will displace. Everyone knows this upper will displace by the x. I'm not using that solution because you know the formula of this one. Everyone knows here eta is equal to F divided by A into X by L. This is the formula, I think. Clear to us? F by A, X by L. X is asked, so X equal to, you can write here in this one, FL divided by A eta, and you have to now put the data. How much force is given in this one? 9 into 10 power 4. Length is 50 centimeters. We can write 1 by 2 here. Area 50 into 50 we can write. No, in this one, oh, this is the site, and then they have given this one is okay, thickness given how much? 10 centimeter. Okay, so we can write area will be how much here? 0.05. They have calculated here 0.05. Okay, yes, and then eta value, whatever eta value is there, we can put here. Possible? Can we do the calculation? Listen, here area is this, like if I take the example, like this, okay? So if you see, then they have given this one is the 50 centimeter, okay? This is the 50 centimeter, and this one is how much? 10 centimeter. That's why area we are not writing 50 into 50, because mostly we are taking the cubes, we are writing 50 into 50, but here we are writing what? This is the 50 and this is the 10. So area we have taken how much? 50 into 10. This is the one key point in this question. 50 into 10 area calculation. This one is the 50. You can see here. Okay. This one is the 50 and this one is what? 10. This side is 10. This side is 50. That's why here area. This part is important because mostly we are habitual of doing the L square. L square means okay, 50 into 50 we write. Okay. Yes, so you have to be careful in this part. Now, and data always they will go simple, okay? They have given average depth of Indian Ocean is about 3,000 meter, 3 kilometer. Calculate the fractional compression and bulk modulus is given, okay? I will not go by this solution here. We'll write bulk modulus is always equal to delta P divided by delta V by V. It means this one delta V by V we have to find. So delta V by V, okay, fractional compressions will be delta P by beta. Delta P is simply rho G H divided by beta. Change in the pressure will be equal to rho G H. Okay, so rho is your 10 power 3, G is 10 I am taking. They whatever they have taken doesn't matter. 10 I will take. And height, okay, we are going to for what depth? 3,000. So I can write here in this one 3,000 divided by beta, whatever the 2.2 into 10 power 9. Here 30, here 30, 60, 70. So you can say this one becomes okay, 3 divided by 2.2. Okay, and here 20 will be left 10 power 2. Okay, if they are asking the percentage, then we can say this one will be how much? You can write 3 by 2.2 becomes 1.36 into 10 power minus 2. This is the delta V by V. I hope clear this one. After the Young modulus, second most important is the bulk modulus. Okay, so this is the one important question on the bulk modulus. That bulk modulus is always equal to delta P divided by delta V by V, and then we get delta V by V. Okay, delta P by beta. Yes, clear? Okay, now we'll go for the next one here. Now, this is the one important thing here actually. Earlier, when one time I asked question from this page, so many people did mistake in this. You know, whenever we are making the pillar, okay, then always base of the pillar is thick. Why base of the pillar is thick? This is the question I am asking. Why base of the pillar is thick? Here pillar is given because we ignore always this line. I asked two questions 2 times. One time, okay, wrong. And then I said you will read. And second time I ask one more question. Listen. If I say this pillar, okay, you cannot make like this. You have to make such a way because this pillar have to support whole load, okay. This total load will be supported at the bottom. That's why bottom you have to make somewhat, okay. Anywhere you will see that, okay, bottom will be always thick like this. We will make like this or like this because this bottom have to support whole load, okay. upper side also some okay here, okay, like this bridge is there or something is there. This load and everything will be supported by this pillar. So cross section of the pillar how to be okay somewhat wider. Okay, now we'll read this one. Okay, so question I asked, that was the pillar. Okay, if you remember that question, you will solve that one. And that question, okay, height of the pillar was asked, okay, from the breaking strength. Okay, if you remember that one. Now, one okay, pillar with the rounded ends, pillar with the distributed ends. Okay, always you make like this. Why the maximum height of mountain? Why the maximum height of mountain on earth is 10 kilometer? Okay, why more than 10 kilometer height not there? If you say na maximum height, okay, you might have heard Mount Everest 8.8 na, more than 10 not there. Okay, so this region can be provided by the considering the elastic properties of rock. A mountain base is not under uniform compression, and this provides some shearing stress to the rocks under which they can flow. The stress due to all the material on the top should be less than the critical shearing stress at which the rocks flow. At the bottom of the mountain of height h, force per unit area due to the weight of the rho g h. Okay, so on each will be the 20 kg, so mg will be 20 into 10 divided by your area, 10 into 10 power minus 4. Okay, this is the clear. Okay, YouTube is I think some problem, some technical problem that is okay beyond our control, but this okay, you will receive this file. Okay, because okay, some things you will listen and something you will revise from there, so it will be better for you. Okay, what are the pressure on a swimmer 10 meter below the surface of lake? Okay, means here, okay, we can say like this is the lake, and they are asking that here, okay, swimmer is there, and then you have to okay find the pressure. You can see here pressure is simply equal to how much? Why I have taken this question? Because people think that we have to only take rho g h. Here pressure will be P naught plus rho g h. Okay, P naught plus rho g h is the total pressure, not. Okay, now YouTube I think working. Yes. And sir once explain pillar topic. Okay, I will explain pillar topic. Okay. Actually, in the pillar topic, what I said that always okay we are making in the pillar. This was the main okay. The base of the pillar is thick. like this we make, okay? Anywhere you will see, either you see at your home, either temple, anywhere, pillar is always thick because it how to handle all the load, okay? Total load will be there. Means if suppose if I say na, this load is suppose M1, this load is M2, okay? Then pillar how to support how much? So they will give the breaking strength. So we can say total weight will be M1 plus M2, okay, into G divided by A. Total weight it how to support, okay? Yes, this is the thing I said. And there I said maximum height, okay, of mountain, maximum height of mountain, if I say, then maximum height of mountain is how much? 10 kilometer. These are the two things I said, okay? Clear? And let me add one more thing here in this one. Maximum height of, in this one question that I asked previously, in which you have done the mistake, I gave that this mass was, okay, like 500 kg, I don't remember exactly. And here, okay, in this one, height was asked and density was given, okay, like density, I can say suppose 4,000, okay, 4,000 kg per meter cube, okay, like this, and height was asked. So you can say, sir, M1, okay, clear, 500, but M2 will be what? Volume into density, okay, volume into density. So we can write here in this one that volume will be area into H into density, which is the 4,000, okay, into your G, which is the 10, divided by A, okay? And this breaking stress was given in that question, okay? I'm talking about the previous exam question, okay? And I asked, what are the A? What are the A? A I asked in that one, okay? This was the thing at that time, okay? Yes. So maximum height, you have to remember, that is the theoretical question. And, okay, breaking strength, okay? Now, density, they are saying here that how much high would the atmosphere will extend. Listen, this is the surface of Earth, okay? Now what happens that in this one, some molecules are there, okay? And as you go up, density of molecule will keep on decreasing, okay? And, okay, like this, okay, beyond this one, nothing is there, okay? After this, okay, here, no atmosphere. So this atmospheric pressure, if I take now here, okay, on the unit, okay, area, how much atmospheric pressure, this will be the rho g h, and everyone knows this, okay, height is suppose h. Atmospheric pressure is always because of the atmospheric molecules, weight of the atmospheric molecule. So we can say weight divided by area. Weight by area means total weight. In this one, we can say mg divided by A. Mass will be volume into density. So AH into rho into G by A. A cancel rho GH. In this atmospheric pressure, everyone knows 10 power 5. Density, they are saying take 1.29. I'm taking 1.3. G is 10 into H equal to 10 power 5. H you have to find how much is the height of atmosphere. What is the maximum height of atmosphere? So you can say this one becomes 10 power 4 divided by 1.3. Roughly, if you calculate, it will become, okay, 8 kilometer. 10 divided by 1.3 around, okay, 8 kilometer. Means beyond 8 kilometer atmosphere not there. If they ask na, then your aeroplanes can go up to what maximum height? Then aeroplane can go max to max up to 8 kilometer. Beyond that they cannot go. If you have seen somewhere, then you will remember that they say that plane is flying at the altitude of 7,000 feet, 8,000. That is the, okay, they always give it in the feet. Maximum is the 8 kilometer, okay? Yes. Now, in this one more thing you will read here, okay? This line here. We should also note that the sea level atmospheric pressure is not always 760 mm of Hg. A drop in the Hg level by 10 mm or more is a sign of approaching storm, okay? This last line, okay? What happens whenever, okay, your storm is approaching? At that time, air molecules will move faster. And if air molecules are moving faster, of course, pressure will slightly drop. So whenever pressure drops significantly, when this drop is more than 10 mm, that is the sign of approaching storm. From here, they can make the statement type question that, okay, drop of 10 meter is the sign of approaching storm or something like this. So remember that pressure is not always 760, it will change. Okay, it can be 1 or 2 mm drop, 3 mm drop is not much relevant. But if there is the more drop, if there is the drop more than 10 mm, then okay, there is the warning, and okay, your department will issue the warning that okay, there is the storm might be coming, you need to be alert. Okay, this is the system here. Okay, now we'll go for the next one here. They are saying in this one next year depth of this one, what are the absolute pressure, what are the gauge pressure, and how much force is acting on this submarine. Okay, listen, I have taken this question just to explain what are the terms, these gauge pressure and absolute pressure, because we know the pressure, but exactly this minute difference between the gauge pressure. So simple, your rho g h is known as your gauge pressure. Okay, if anyone is asking what is the gauge pressure, then simply rho g h is the gauge pressure. If they are asking absolute pressure, then P naught plus rho g h. P naught plus rho g h is known as absolute pressure. This one is the gauge pressure. These two terms you have to remember: gauge pressure, and this is the absolute pressure. They're asking in the first one, what is the absolute pressure? Calculation is nothing, simple. P naught plus rho g h. P naught and plus rho g h value, we got this value. Okay, calculation is easier. Okay, then they are asking only gauge pressure. Gauge pressure is simply what? Rho g h. This is the rho value, density they have given. This is the density rho g, they have taken 10, and this is the h. Okay, so you can just put the rho g h. Okay, all the values. We got 103 atm. Clear? Rho g h 103 atm. Okay, by putting the data here, 1.03 into 10 power 3, 10, and we got 103 atm. See, they are asking how much force will be there. Pressure outside the submarine is how much? Outside, if you say P naught plus rho g h, means this is the, suppose if I say, okay, this is the your submarine here. Outside pressure here, P naught plus rho g h, and inside pressure is what? P naught. So we can say what are the net pressure? You can say net pressure delta P is basically your rho g h, which is equal to the gauge pressure only, and force you have to find. So force will be equal to delta P into A, and this area is given here. This is the area, 20 into 20 is 400 centimeter square. You will multiply with the your gauge pressure. Clear this question? So gauge pressure simply rho g h. Okay, and we can put the value of rho g as well as h. They are asking that how much total force will be there. Out of the submarine, pressure will be P naught plus rho g h. Inside will be the P naught. So net will be the rho g h. Okay. Now, this is the question again here. Okay, they are saying two syringe of different cross section. Okay, or you can say in the single syringe also you can take single syringe is there, different cross sections are there like this. Okay, if I draw here like this, this is the thing. Okay, either you can see this one or two different. Okay, filled with water are connected with a tightly fitted rubber tube filled with water. Diameters are given here. This one is the 1 centimeter, and this one they have given here 3 centimeter. Okay, they are saying find the force exerted on the larger piston when the force of 10 Newton is applied to the smaller piston. Okay, these are the questions from Pascal's law. Okay, Pascal's law, earlier it was not specified in the syllabus. Last year they have specified. It was always in the NCERT. So it was there, so we used to do always, but last year specified. That's why this question becomes more important. And what Pascal's law is saying, it is simply saying that F1 by A1 equal to F2 by A2. Pressure gets uniformly distributed. F1 by A1 equal to F2 by A2. Okay, so we can say F2 we have to find. So from here we get F2 will be equal to A2 by A1 into F1. Okay, and now this is the easier calculation. Without this, I will do the calculation. Let's do it. And NCERT doing sometimes long calculation. F1 is given 10 divided by area, I correct pi r square. Okay, and they are saying force on the larger piston, means this will be how much here? Your 9. Okay, equal to, we can write, find the force on the large piston when applied to the, no, this is the, okay, large piston we have to find. So this is on the small piston, okay. F2 we have to find on the, okay, large. So we can write here pi, and this 3 square will be 9. Pi you can cancel, F2 becomes 90, okay. So this is the much easier calculation. F1 by A1 equal to F2 by A2 from Pascal's law. F1 by A1 equal to F2 by A2, okay. F1 by A1 equal to F2 by A2. Clear? Now, then they have given the second part also. If a smaller piston is pushed through 6 centimeter, both questions are important. A smaller piston is pushed by this, then how much will the larger will move? You know, volume always same, okay. You can say this one coming from the equation of continuity or whatever, that we have to write like this: A1 into X1 equal to A2 X2, okay. So we can write A1, okay, means if the smaller piston is, okay, smaller piston means area will be 1, it is the 6, and larger piston area will be how much here? Your 9 into X2 we have to find. So you can say X2 will be equal to 6 by 9, which is the 2 by 3. A1 X1 equal to A2 X2. You can say A1 V1 equal to A2 V2. From there we can write this one, A1 X1. In the smaller one, okay, like this we can say, smaller one we are moving by 6 here. So we can say area will be, because radius is 1, so square, because pi I am cancelling. So 1 into 6 equal to 9 into X2. Pi will be cancelled from both sides. Yes. Now, next one is given that again from the Pascal's law. If you see in the NCERT, they have given 2-3 questions on the Pascal's law, and maybe they can ask also. So they are saying in the car lift, like this is the your lifting thing here, okay. Here we put our car, okay, means your we will put the car here like this, and this side will apply the force, okay. They are saying that force F1 we are applying on the, okay, radius 5 centimeter, and pressure is transmitted to the radius of here 15 centimeter, and mass of the car is 1350. This mass is 1350 kg. They are asking in this one what are the F1. You can see, use the same thing, F1 divided by pi r square. So pi and this r square I'm writing 25. Pi will be cancelled, 10 power minus 4 also cancelled, so not putting that one. 1350 into 10 divided by here 50 pi, and this one we can write 15 into 15 here, okay. And I hope calculation can be done by all. Yes, easy calculation. Okay, because pi you can cancel, I'm not interested, okay. You have to find this your F1, okay. Again from the Pascal's, F1 by A1 equal to F2 by A2, okay. We generally ignore the Pascal's law because that is a very easy, but you can see in the NCERT they have given, okay, 3 questions. Now, this is the one question from the your Bernoulli actually, okay. And modified question will be asked. How I did 2 questions, one from the solved example, one from the exercise also taken, okay. Fully loaded Boeing, okay, they are saying fully loaded Boeing aircraft has the mass of this, okay. This is the mass of the Boeing. Its total wing area is 500, okay. Total area is 500. It is a level flight with a speed of 960. What are the meaning of level flight? Like this is the your, okay, Boeing we can say here, okay. Now, in the level flight means downward mg will be there and upward force will be there, which will be because of the your pressure difference, okay. And this force will be because of the pressure difference, so delta P into A. So we say delta P into A how to be equal to mg. They are asking estimate the pressure difference between the lower and upper surface. Up to this is the simple question of NLM, you can see. There is no Bernoulli used. They are asking how much pressure difference. You know that in the level, at a particular level, upward force and downward force, how to be balanced. So delta P into A must be equal to mg. So we carry delta P, we have to find area. I can say how much, 500 given, mass is given 3.3 into 10 power 5, g is 10. We can easily calculate this one. If you calculate, then delta P becomes here 6.5 into 10 power 3, okay. Now this is the delta P, okay? Question over. Sometimes they are only asking this small part. Now if they want to use the Bernoulli, then here you have to use delta P as half of rho V2 square minus V1 square, okay? And here they are asking the fractional change. Chances of that is lesser to be asked. Maybe one velocity will be given, other will be asked. So we can say delta P always this one and 10 power 3, because fractional change becomes somewhat more calculations, okay? I'm not going to say also that one. So delta P always remember that, okay, in the Bernoulli, this is the one formula we are getting half of rho V2 square minus V1 square. And in this formula, velocity will be given. With both velocity given, they will ask delta P. If delta P given, any of the velocity given, they can ask the second velocity. Like in this question, we have calculated first of all delta P. If they are given either upper velocity, either lower velocity will be given, and then we can, okay, find one of the velocity. Clear? Okay. Fractional thing, okay, chances are lesser because it goes a little bit lengthy, okay? But you, okay, those who want, they can see this part, okay, fractional part, okay? I don't think. Then taking this question from the exemplar, an ideal fluid flows through a pipe of circular cross section made of, okay, 2.5 and 3.75 ratio of velocity. They're asking, you will use this one, A1 V1 equal to A2 V2. Now we can write here in this one V1 by V2 we have to find. So we can say V1 divided by V2 will be equal to A2 by A1, and which will be equal to your diameter given. So we can write it will be equal to D2 by D1 whole square, and D2 is 3.75 divided by 2.5 whole square. I hope calculation you can do easily. Yes. Question from exemplar from the equation of continuity, A1 V1 equal to A2 V2. Yes. And yes, you will practice. When I'm saying that, you will do the calculations. You will do it, okay? Because this whole, I am taking maybe 5-6 hours, but whole, okay, you can do max to max in the 2 hours. In 2 hours, all the questions will be done. It will not take much time, okay? Now, next one is given in the, okay, this is from the NCERT, the question number 14. In the test experiment on a model aeroplane, okay, in a wind tunnel, flow speeds on the upper and lower are 70 and 63 respectively. See this data, 70 and 63. What is the, okay, lift on the wing if area is given? You know this formula just now I said, delta P equal to half of rho V2 square minus V1 square, okay? Now, to do the calculation much easy way, you can use A square minus B square, means you can write like this, rho V2 minus V1 and other bracket V2 plus V1. Let's put the data here. So half rho is here 1.3, this minus this becomes 9, and this okay, not 9 here, 7, okay, because 70 and 63 given, and this one you can write here 3 and 133. This is the, okay, calculation you will do. This will be the delta P. Once you got your delta P, then you will find the force, and force will be equal to delta P into A, okay? Yes, this will be the, okay, your lift, total lift, okay? So this delta P formula you have to remember. I have included 2 questions of Bernoulli based on the aeroplane in this one, because Torricelli is very easy. In Torricelli, they have not given any question also in the NCERT. Root 2GH, I think anyone can do, okay? So they have not given, so I'm not taking, because our program is strictly NCERT. Only thing that I have added a little bit extra is the exemplar, because I thought that yes, exemplar is always more relevant. So, okay, added that one. So half of rho V2 square minus V1 square, and then we can write like this, half rho V2 minus V1 and V2 plus V1. Just putting the data and getting this total lift delta P into A, okay? Now this question is from the, again, NCERT, and this is the question from viscosity, okay? Actually, this way practically we determine viscosity of liquids, practically determined using this setup, okay? So they are saying in this one metal, okay, block of area is given, and this 0.02, okay, if you say here, if you multiply with the 10, it will become 0.1 Newton, and thickness is given, and this is the thickness given, and here they have given the speed. If you write here that okay, F equal to, this is the formula, eta A dV by dx. This is the formula in the viscosity that I am going to use here. Force, if I write that it is the 0.1, eta I have to find, area they have given 0.1, dV means what are the relative speed given here 0.085, 0.085 divided by dx means thickness. This thickness is given in the mm, so I will convert here. So this becomes 0.3 mm means 10 power minus 3. Can you get that eta here? Possible? They can see yes in the measurement practical. Okay, this is the practical thing here. If you see in this diagram, that's why I have taken the diagram also. Measurement of coefficient of viscosity. So measurement of coefficient of viscosity. Okay. 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 And one more thing. Very special point, this one. This one. Viscosity of liquid decreases with temperature. Viscosity of liquid decreases with temperature while it increases in case of gas. Remember for the theoretical question. For theoretical question, you have to remember this thing, okay? Viscosity of liquid decreases with temperature while it increases in case of gases, okay? Now, this is the question from the terminal velocity. I will write the formula of terminal velocity because this is the directly formula based question. V equal to 2r square g rho s minus rho l divided by 9 eta, okay? V equal to 2r square g rho s minus rho l by 9 eta. V equal to 2r square g rho s minus rho l by 9 eta. It should be remembered from here. A very small question will be asked. Like in this question, that radius is given and terminal velocity is given 6.5, okay, 6.5 centimeters. So I can write in the 10 power minus 2. 2 here, r square, radius, so 2 into 10 power minus 3 whole square because mm. G I have taken here 10. Rho s minus rho l, you can put the data, both the data given here, okay. This is the rho s minus rho l, 8.9 minus 1.5, which becomes here 7.4 into 10 power 3 divided by 9 and eta. You have to get eta. Possible? Yes. Appears like lengthy question, but question is not lengthy, and you can do approx calculation also, okay. It is not that you have to do always exact calculation. You can do the approx. Yes. Possible, na? Very good. We are reaching close to 50 slides. Now, this is the question from surface tension. I have taken full page here, okay, because I wanted you to read this one time, okay. They are saying here, lower end of the capillary, okay, it's dipped, okay, 8 centimeter below the surface of water, okay, like this, okay. Here we are dipping this one, okay, dipping. Then they are saying that we have to, okay, we have dipped this one, okay, and then we are how to blow one hemispherical bubble, okay. Now, in the hemispherical bubble, what is there? Whatever the radius of tube, same will be the radius of bubble, okay. They are saying, what is the pressure required in the tube in order to blow a hemispherical bubble at the end in water? Now, here we have to blow that bubble. Like you do know, whenever you are taking the fruity or something, you, okay, yeah, you misusing that straw, you just do like this, okay. So bubbles are formed. The same thing question. Only thing I have taken, because whenever bubble is there, okay, you take 40 by R. This is the bubble in liquid. bubble in water. So we can say excess pressure will be how much? 2T by R. So read, excess pressure in a bubble of gas in a liquid is given by 2T by R. Okay, 2S by R they are writing, where S is the surface tension. You should note there is only one liquid surface in this case. For a bubble of liquid, in a gas, there are the two liquid surface. Like if I say soap bubble here, okay, then soap bubble will be how much? 40 by R. But here you will take how much? 2T by R. That they are trying to say, okay, in this question. That's why I have taken this line here. That excess pressure you will take how much? 2T by R. Okay, inside liquid you have to take how much? If they are giving the inside liquid, okay, then you will take how much? 2T by R. Okay, and this is your okay, soap bubble or any of the bubble in the air, okay, then we can say formed in the air, then 40 by R. Again I will read here. For a bubble of liquid in a gas, there are the two liquid surface. The formula for excess pressure will be how much? 40 by R. The radius of bubble is this. Now we can okay, put the data here. So they are asking total pressure we have to find inside this one. So you can say total pressure inside this, because here pressure we can write, okay, so we can write P naught plus 2T by R, and then data is there, okay, we can how to just put the data. Radius we have taken same as the hemispherical is there, okay. Only thing here that I have taken this question 2T by R and 40 by R, because soap bubble is always in the air. This is always in the air, okay. So you can say liquid means okay, here this one written here, gas, bubble of gas, okay, bubble of gas in liquid if given, then you will take 2T by R, and liquid bubble in gas or air, okay, then you will take 40 by R, okay. This is the conclusion you got. This conclusion everyone how to remember. People keep on doing the mistake, okay. Bubble, okay, made of bubble of gas in the liquid, 2T by R. Liquid bubble in the gas, 40 by R, okay. Huh? This line, okay, taken from here, okay, taken from here, okay. This one added in, especially extra. If any bubble, okay, made of air or gas is there in the liquid, then 2T by R, otherwise 40 by R you will write, okay. Yes, I hope clear. We'll go next one here. So next is the our thermal properties of matter, okay, and okay, we'll take some short break, and then we'll continue up to around 1:15. We will continue, because just now we have finished how many pages here in this one? Almost 50 pages are over, 80 pages are left, okay, and we have around 3 hours also, okay. Yes. Okay, so I'm going to have 15-minute break, then we'll meet. Okay, you can also have a break, because you also need the break, because we are sitting mono, okay, it becomes monotonous. Okay, so we will be back quickly. Okay, bye. Coming. Maximum 15 minutes. Okay, right now time is okay, 36. Okay, I will be back by 46. Before okay, 50. Hello? Voice not coming? Now? Now coming? Now voice. Yes, voice clear? Hello? Now clear? Okay, 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 okay. Now, so we can say in this one, your linear expansion, okay, one is the linear expansion. Next one is your areal expansion. Next is the volume expansion. These three formula you have to keep in the mind that here delta L by L means fractional change directly. That is the alpha delta theta. Here we carry 2 alpha delta t or delta theta, and here this is the 3 alpha delta theta. This one we can write like this also, the delta L here equal to L alpha delta t. Here we get delta A equal to in this one 2 alpha A delta t. 2 alpha is written as beta also, so beta, okay, A delta t, and here we can say delta V equal to your okay V and 3 alpha delta t, and 3 alpha is known as gamma also, so we can say V into gamma delta t. Okay, you got the relation also that here in this one, this is the 1D, this is the 2D, this is the 3D. That's why we are getting here beta is always 2 alpha, gamma is equal to 3 alpha, alpha beta and gamma relation is always 1 2 and 3. Okay, alpha beta gamma relation 1 2 3. Okay, so these are the formula here. Now we'll take a question. These are okay. In this one, this is the one graph you have to remember. Whatever graphs are there in the NCRT, all the graph you have to remember. This is the fixed graph you have to keep in the mind. Coefficient of volume expansion of copper as a function of temperature. Listen here. Whatever quantities depends on the property of material, your alpha, beta, gamma, all depends on the property of material. If they depend on the property of material, these depends on the temperature also, because as temperature will change, material will not have same configuration. So material configuration will change, means property of material will change. That's why whatever quantity which is dependent on temperature will also change. Okay, so we can say alpha beta gamma depends on the your properties of material. That's why they will change with the temperature, and this variation is for the volume expansion of the copper. Okay, as it is graph you have to keep in the mind. Okay, now, there is the one, okay, I have taken this paragraph that what happens by preventing the thermal expansion of a rod. Like if this is the rod here, and if this rod, if I keep between the two rigid support, okay, we are preventing this thermal expansion of the rod by fixing its ends rigidly. Okay, you can see here by fixing its end rigidly. Clearly, the rod acquires a compressive strain due to the external force provided by the, okay, here rod want to okay, it wants some elongation, but these rigid support will apply some force, and this force will try to compress. That's why this is known as your compressive strain, or we can say this force. If they are asking what the type of force, then we can say type of force is the compressive force. I am writing directly formula of this one. You have to remember this compressive force Y A alpha delta theta. Okay, this force, okay, known as your compressive force, okay, compressive force is given by Y A alpha delta theta. Directly they can ask a straightforward question like here. Okay, in this example they are trying to say, so they will give all the values here. Okay, Y, okay, Y A, and this delta L by L is the alpha delta theta. NCRT is using different method to solve, but remember this formula. Okay, force equal to Y A alpha delta theta. Suppose they are asking anywhere stress, then you can say stress will be nothing but the your force by area, which becomes in this one, okay, Y alpha delta theta. And if anyone is asking the strain, okay, this strain or stress all are the compressive type, and this will become delta L by L, which is the alpha delta theta. Okay, so this one you have to remember because they have specified. From there they can make one question like here they have given also, like area given here in this one, alpha given, okay, area given, alpha given, and they might have given temperature change also. Okay, so we can put all the data in this one. Okay, delta T, okay, whatever given we have to just put the data. Young modulus also given. Okay, so all the data they will give, and we have to put the force equal to Y A alpha delta theta. Stress force by area, and strain will be delta L by L, which is the alpha delta theta. Okay. Now, then this is another question. A blacksmith, okay, how to fix, okay, iron ring on the rim of the wooden wheel. Okay, this one is the your wooden wheel, and here we have to put the your rim. Okay, we have to put the rim on this one. Now you want, okay, you know that if you have to put the rim, okay, rim cannot be loose, okay, because if rim is loose, it will not have the snug fitting. Okay, so if you want tight fitting, then your rim have to be somewhat small. Okay, you will heat this rim will expand, then you will cool it down, so it will have the tight fitting. So rim we have to make somewhat small. Okay, they have given in this one the diameters of rim and irons are, this is the, okay, so we can say how much expansion, okay, you need. When this one will become equal to this, then only it will have tight fitting. So we can say here we'll use the same delta L equal to L naught alpha delta theta. If they are making this question, maybe calculation they might give much easier to you. Okay, easy calculation they will give. Or you can take approximation, like you can say how much change is okay needed here. You can say this will be the your 321, and this is the 431, and this is the 0.012 equal to L naught. L naught you have to take this value, but I will round off. I will take only 5.2. 5.2 alpha will be given here. Okay, like 1.2 into 10 power minus 5, and you will get the delta theta. Okay, delta theta. Once you get the delta theta, after getting the delta theta, you will write this is the final temperature minus 27. Okay, and then you will get the your T2 temperature. Clear this one? Yes, can we do like this? We have given these type of questions multiple time in the examination also. Okay, data might be changed. Simple delta L equal to L naught alpha delta theta. This rim you have to, okay, expand so that it becomes this, then only tight fitting will be there, and delta L is this. L naught we can round off and then okay, do the calculation. Remember at the last delta theta you will get temperature change. You have to write T2 minus 27 here, okay, to get the final temperature. Now this question is okay, from the calorimetry. If you see, okay, they are saying a sphere of okay, this aluminum is placed for the sufficient time in a vessel containing boiling water, so that sphere is at 100 degrees Celsius. Means sphere becomes at 100 degrees Celsius here. Okay, this one is the sphere. Okay, 100 degrees Celsius. Okay, and mass they have given, this sphere is 0.047 kg. Okay, now they are asking in this one, it is then immediately transferred to this copper calorimeter containing 0.25 kg water at 20 degrees Celsius. The temperature of water is this and attains the steady state. Calculate the specific heat capacity of the aluminum. Okay, and here they have not given. Okay, in the question they have given. Okay, specific heat of copper given. Okay, specific heat of copper given. Okay, because I have not taken the solution here. So what will happen basically, heat released equal to heat absorbed. This one you have to use. Who will release the heat? You know that this is the 100 degrees Celsius and this comes finally at the 23 degrees Celsius. So this will release the heat. So we can say how much heat it will release. Okay, that will be the ms delta theta. So 0.047 specific heat we have to find, and delta theta you can write in this one how much? Yes. Okay, 77. Heat absorbed. Okay, heat absorbed by, okay, heat taken by copper calorimeter plus water. These two will absorb the heat. This heat you can calculate because value will be given to you. Like we can get 0.14 specific heat of copper given to you. Delta theta, initially it is at the 20, finally becomes 23. So here delta theta will write 3. Mass of water is 0.25. Specific heat of water, okay, we can put here in this one, plus, okay, space 0.25. Specific heat of water 4200. Delta theta is 3. Then you will equate as copper will be given to you. Okay, then you will get this specific heat of Aluminium, you can say heat released equal to heat absorbed. Your aluminium will release the heat, copper will take the heat, as well as water will take the heat. Okay, this one is clear. Aluminium will release the heat, copper will take the heat, as well as water will take the heat. Okay, aluminium sphere which is at the high temperature, that will release the heat. Okay, so here you have to just okay, check in the question who is releasing the heat and who is going to take the heat. Okay, because someone is coming from 100 to 23, it means that is releasing the heat, and these copper calorimeter as well as water, they are going from 20 to 23, means they are taking the heat. So heat released equal to heat absorbed, heat released by the aluminium equal to heat taken by the calorimeter plus water. Okay, now these are the things about the your triple point. In the triple point, okay, first of all, for water you have to remember the data. Okay, that for the triple point of water, okay, this temperature is, okay, 0.01 degrees Celsius, or we can say 273.16 Kelvin, okay, in the Kelvin, and pressure is this one, okay, in the ATM, okay, 0.006 ATM or 4.58 mm of Hg. These value for the water should be remembered. This is in the ATM and this is in the mm of Hg. No need for CO2. This graph is for CO2, no need. Okay, for the water you have to remember. Okay, for the water triple point is 4.58 mm of Hg. If they are asking in the mm of Hg, only temperature is not sufficient to say triple point. Both the conditions should be there. Pressure condition you have to say as well as temperature. So temperature is 4.58 mm of Hg, and this one is the 273.16 Kelvin. If they are asking the ATM, then 0.006 ATM, or in the degree Celsius 0.01 degrees Celsius. Okay, first of all, this these values you have to remember. Okay, clear? These values we can remember. Now, what are the use of this? Use of this is to figure out. Okay, what are the use of this one? I will write here. Okay, used to find. Okay, used to find. Okay, effect of pressure on melting point and boiling point. Okay, on melting point and boiling point we find the effect. Listen, in this one, this curve solid to liquid, this curve, this line is representing solid to liquid. So this one is known as solid to liquid, means your solid to liquid, we can say this is known as your melting curve. I can say, means this one represents the melting. Liquid to vapor, this is known as boiling. Here we can write. Okay, this represents the boiling. Okay, and this one is the your saying solid to vapor. Okay, so this one we can say is known as your sublimation. Okay, so three things are there. Okay, this is the sublimation, this is the melting, this is the boiling here. Okay, now if I say same here in this one, okay, here also solid to vapor, this will be the sublimation, solid to liquid, melting, and this one is the your boiling. Okay, now CO2 not needed or written. If pressure increases, I'm talking only for the water. Okay, if pressure increases, then you can see this graph. If you go upside, then your temperature is decreasing, means your melting point will decrease. And if you increase the pressure, if you are increasing the pressure in this graph, if you see this graph is like this, if you increase the pressure, then you can say your boiling point will increase. Okay, this is for water. Okay, here this graph is like this. In this one, if you say if you increase the pressure, melting point decreasing, but here you can see that this is the inverse type graph, this is the direct type graph. Pressure increasing, boiling point increasing, and here we can say pressure increasing, melting point decreasing. Okay, for the your okay, water you have to remember all the things. Okay, not for the CO2. In the CO2 you can say both the graphs are almost okay, direct type. Now then comes this question again from the calorimetry. When this much ice is mixed with this water containing okay, resultant temperature, calculate the heat of fusion of ice. Okay, so you can say in this one, for these questions we write this side your ice, this side your water, okay. This side we write higher temperature, that side we write lower temperature. Well, this one will absorb, this one will release. They are saying in this one that finally, okay, 6.7 degrees Celsius is the mixture temperature. This one was 0 degrees Celsius, and this is the 50 degrees Celsius, okay. Now, specific heat is given and they are talking about all the data in the SI units. You will take SI unit only here. Now we can write mass is given 0.15 kg, and this one is given here 0.30 kg, okay. Now, so you can say it will be, okay. So now what will happen in this one, that first of all what will happen, MLF plus MS delta theta. Okay, here first it will melt and then temperature will rise. And here we can write only MS delta theta. How much mass is there? We can say 0.15. LF we have to find plus 0.15. It becomes water. That's why specific heat of water is this. Okay, 4186. Delta theta you will write here 6.7. Okay, equal to, we can write here 0.3 into specific heat of water 4186 into and 50 minus, okay, 6.7, okay, it becomes 43.6. You will take this data, that side, it will be, okay, subtracted. Can you get the LF now? Possible? Okay, little bit calculation is there. You can take approximation like 4186, you can take 4200, okay, 4200, and then you have to get the LF, okay. Yes, so ice is absorbing the energy and water is releasing the energy, okay. So we can say absorb energy equal to released energy. Ice will first melt, so MLF, then we will write MS delta theta, and water will release the energy till its temperature becomes 6.7. So we can say here how much energy it can release. There is the 0.3 into 4186 into 43.6, okay, will be the release one, okay. Calculation you have to do, okay, some approximation will be working always. Then they are saying here, next question, calculate the heat required to convert 3 kg of ice at minus 12 degrees Celsius kept in a calorimeter of, okay, you have to convert to steam. A specific okay, values they have given, and in this one they have not given any values for the calorimeter, so you will not consider calorimeter. You will take first of all this ice at minus 12 degrees Celsius will be going to ice. I'm writing the flow here 0 degrees Celsius, then ice will go to your water 0 degrees Celsius, then this water will go to water 100 degrees Celsius, and then water will go to steam 100 degrees Celsius, okay. Value you will put, and now ice to ice, so this will be the MS delta theta, mass specific heat is given, you can put here. Here it is happening MLF, this will be again MS delta theta, and this will be MLV. Can you put the data now? Well, mass is 3 kg, so like you will put here 3. I will say that better, if you want, you can take your own data also. Like you can take here specific heat of ice half. I'm taking, okay, our data because we know this, okay. Here we can write your 3, okay. But remember, this is the 10 power 3 here because kg is there. We are taking in the gram. So, okay, everywhere 10 power 3 will be there, okay, in whole calculation, I can say. Okay. In whole calculation, we can say 10 power 3, okay. Like this, I can write. Plus this becomes here 3 into 80, plus this becomes 3 into 1 into 100, plus this becomes 3 into 540, and then 10 power 3, this is the answer. If you don't want to take data given here, you can use your own data, but if some data is given, I will say go with that data, whatever given data is there, go with the given data always, okay. Yes, flow should be clear to you, okay. What is happening first? Ice minus 12 to ice maximum temperature can be 0, okay. Ice cannot be more than 0. Then after that, ice 0 ice will be converted to 0 water. Then this 0 water will go to 100 water. Water cannot be more than 100. It how to change the phase? It becomes steam 100, okay. Now, this question is from the conduction here. If you, okay, they are saying that we have this, two are connected. What is the important here? Temperature of junction is always important. That what is the temperature of junction? From this side energy coming and this side energy is going. Okay, so this temperature we can assume as theta, or they have taken T naught. Okay, so T naught we have to find. Okay, so what happens? Energy coming equal to energy going. So we can say this one is suppose your K1. Okay, this one is your K2. K1, K2 values are given here, and length also given. Length they have taken same. Okay, length and area same. You can say here length, area, and this length and area both are same. Okay, so now I can write here K1 into A. Okay, K1 into A. T1 means 373 minus T naught divided by L equal to, we can write K2 into A. T naught minus 273 divided by L. L will be cancelled. K1, K2 value you have to put here. Some calculation, but less calculation. Okay, heat incoming from the hot end, okay, to the junction, and going from junction to the cold end. Okay, coming from hot to junction and going from junction to the cold. Yes. So here we can write in this one that K1 value, whatever the K1 value is there in this one. What are the K1 value here? 79, 373 minus T naught. And here we can write K2, which is the 109. And here we can write T naught minus 273. Okay, your calculation will be done. Okay, first part. Okay, second part, they're asking equivalent thermal conductivity. Okay, equivalent thermal conductivity, this is the series, and in the series, K equivalent, this is the formula. I'm writing the general formula. Okay, you will put the L1 plus L2 divided by L1 by K1 plus L2 by K2. However, in this case, length is same. Okay, and if length is same, this becomes 2K1 K2 by K1 plus K2. But remember always general formula. Okay, general formula you have to remember. Okay, and then they're asking that what is the total heat. Total heat, you can, okay, you got the K equivalent, you have the area, you can find total heat. Okay, K equivalent into A delta theta by L. Okay, this will be the total heat. Okay, so finding total heat is much easier. K equivalent you have to find, and most important is here temperature of junction in this one. Okay, how to find temperature of junction? We can say heat incoming, okay, towards the junction, and then okay, heat going away from the junction towards cold part. Okay, that is written here K1A. Okay, higher temperature minus junction temperature by L. This is the formula K delta theta by L equal to K2A T naught minus 273 by L. Okay, and this is the formula, general formula you have to keep in the mind. L1 plus L2 by L1 by K1 plus L2 by K2. Now, this is from thermodynamics, starting of the thermodynamics. First question from the thermodynamics, this is the equation Q equal to, if you remember, okay, that is written delta U plus P delta V, which is the W means Q equal to W plus delta U. On this, they have given this question that what are the change in internal energy for 1 gram of water? Consider the change in internal energy for 1 gram of water. So for 1 gram of water, Q will be equal to mLV with the 1 into 540. So this becomes 540 calorie. Okay, 540 calorie. Okay, and if you convert into joule, then you can write 540 into 4.2, which will be equal to 2256 joule. Okay, this is the Q. Okay, Q. They are saying water has volume. Okay, see this line here. Okay, this they will give. Okay, already this question is asked in the PYQ, and they have not asked one time, 2-3 times. 1 gram of water has the volume 1 cc, and in the vapor phase 1671. So if you want to calculate, this is the Q calculation. Then we'll calculate work. Work will be equal to P delta V. Pressure, if you write here, then pressure is how much? Atmospheric pressure, so 10 power 5, and then we can write this one will be equal to 1671 minus 1. So it becomes 1670 into 10 power minus 6. Okay, if you calculate this thing, okay, then we are getting how much here? 167 joule. Okay, they are written 169. Okay, but because they have not considered this 1671 minus 1. Okay, but you have to take minus 1 because V2 minus V1 work is always equal to P delta V. They have taken the V final. Okay, so 167 joule, and then you can write your delta U will be equal to Q minus W, which becomes 2256 minus 167. Clear? Can we do it? Okay, so this is the very important question. Not in the solved example, not in the exercise, not in the exemplar. This is the hidden question in the your theory. Okay, sometimes good questions are hidden in the theory. Okay. Now, these are the two questions I have taken from the exercise. Okay, means good questions are there. Like in the examination, also I have asked multiple times this first one. If you see, geyser heats water. Okay, flowing at the rate of 3 liters per minute. Means this is the 3 kg I can say per minute. 27 to 77 means this is the 50 degrees Celsius. And if the geyser operates on the gas burner, what is the rate of consumption of the fuel? Okay, so we can write first of all how much energy is okay required for this one. So ms delta theta, mass you can write 3, specific is 4200, delta theta is 50. This much joule is required. Okay, if you want to increase the temperature, then this much heat ms delta theta is needed. How you will get this ms delta theta? This ms delta theta will be coming, okay, ms delta theta, so 3 into 40, 200 into 50. This will be coming by burning the fuel. You have to burn the fuel, okay. And now we can say how much, if m gram, okay, if okay, m gram, a small m gram fuel, okay, used, okay, a small m gram fuel used, then they are saying 1 gram gives this much energy. So if a small m gram fuel you are going to use, because you need this much energy, okay, this much energy needed. If you are using a small m gram fuel, then total energy will be 4 into 10 power 4 into a small m. You will get this value of a small m here. Yes, can we do it? Possible, na? Yes. Easy calculations you can do. Small m you have to find, okay. A small m you have to get it, okay. Now, so first what we got, how much okay heat is needed to raise the temperature. Heat required to raise temperature is how much here? Ms delta theta, okay. Total heat required is the ms delta theta. And then we can say here, okay, how you will get this heat? Of course, by burning something, okay, by burning fuel or okay, we can say petrol, diesel, whatever you want to burn. So if m gram fuel we are using and 1 gram fuel, they have given that heat of combustion is this. 1 gram gives this much energy. If you use m gram, then how much it will give the energy? 4 into 10 power 4 into m is the total energy. This energy how to be equal to the required energy? We can get the value of m. If you see the second question that I have kept here, what amount of heat must be supplied to this nitrogen at room temperature to raise temperature at constant pressure written here? You know, constant pressure heat required is always NCP delta T. Sometimes they ask very basic questions. NCP delta T, okay. Now we can say in this one, molecular mass is given and moles not given. So you can say moles will be equal to mass by mw. So 2 into 10 power minus 2. Okay, this one is given in the kg. So molecular weight also will take in the kg, 28 into 10 power minus 3. Cp, nitrogen is the diatomic, and diatomic you will write how much? 7R by 2, and delta T is 45 degrees Celsius, okay, 45, okay. Temperature change in Kelvin and degree Celsius is always same. Now you have to do this calculation here, okay, easy calculation, because you know that here 2 will be cancelled, okay. This will be here 4, R value they have given 8, okay, 8.3 you can put and then multiply, easy. We can do these two questions I have taken from the thermodynamics, because I have taken some more questions, but these two, okay, first two and then some last also I have taken from that. These are the exercise questions, okay. So first one for the fuel and this one is for the directly NCP delta T based question, okay. Now this one is the one question, good question from the, okay, your graph. They are saying in this one that a thermodynamic system is taken from, okay, original state to intermediate state by linear process shown in figure, okay, in this one, okay, and they are saying its volume is then reduced to the original volume E2F by an isobaric process, okay. Calculate the work done, okay, by the gas from D to E to F, okay. Now you know that here to here only they are asking this one, okay. So we can say this one, if they are asking, we can find the total, because work in this process is what? Zero. Work in this process is what? Zero. I can find total. They are not asking total here. Listen again. Okay. They are not asking total, but this one is the ISO, correct na? If I say W total, then W total will be equal to what? W DE plus W EF plus W FD. Okay. And total will be equal to what? Area, okay, but WFD is what? Zero. So I can say WD plus WEF equal to what? Area. Okay, they are asking only here in this one, find the work done by the gas D2E and E2F. So we have to just find the area, because in this one work is zero. That's why I'm finding total area. Okay, total area. So we can say half of the base. Base is how much here? Your 3. Okay, so we can write 3, and height is your, this is the meter cube, so no need to change, and that is the 300. Okay, so 300 we can write, this one becomes 150, and this is the finally 450. Okay, listen, 450 is the total. They are not asking total. Then why you have calculated total? Because you know this plus this is equal to total, but this one is zero. That's why this plus this is equal to the total. That's why I'm finding the total in this question. Clear? I hope, okay, all got this one. So sometimes they will try to trap you like this in this one, okay. If they ask total, anyone can do, just we have to directly find the area, okay. Lot of people might leave this question that, oh, they are not asking total, then how we'll find? So they will either, they will waste the time, they will find first this one individually and this one individually, they will add, okay. You know that if they are asking like this, we can say total, because here work is zero, okay. Now, coming for the KTG. In the KTG, this is the first graph given, and this graph earlier, it was very, very important in the chemistry also, okay. Now gaseous state, okay, I think not there. So in the physics, you have to remember, this is the theoretical point written. Real gases approach ideal behavior at low pressure and high temperature, okay. Real gases behave like ideal gas at high temperature and low pressure, okay. Real gases behave like, okay, ideal gas at high temperature and low pressure. They approach towards ideal behavior, okay. Now we know this temperature is T3. It is, this line is the ideal gas line, this one, okay. This one I can say it is the ideal one. I will draw green line here. This is the green, and okay, green one is the ideal. They have to go towards the ideal. This pink one is the your real gas. You know, real gas will go towards this, okay. It will go towards this, okay, we can see ideal behavior when you increase the temperature. So when I'm increasing the temperature, it is quite close. When I increase further, it is again even closer. So we can say this temperature, this temperature, this temperature relation they will ask. You know that as we are increasing the temperature, then only it will go towards the ideal line, towards the green line. As we are increasing the temperature, it can be close to the ideal line, okay. As we increase the temperature, it will be closer to the ideal line. So we can say T1, T2, this is the T3, T2, T1, 100% T1 is greater than T2, and then T3. This is the less temperature. I increase the temperature, we are even close. I increase further, we are very, very close to this one, okay. So this first graph is clear here. Now, this comes here, okay. They are saying a flask contains argon and this one, okay. This is the much easier. Just average kinetic energy per molecule, okay. Average kinetic energy per molecule, you know, it will be given by, okay, average kinetic energy of any ideal gas. Listen here, why I have taken this question. Average kinetic energy, okay, average kinetic energy of any gas, monoatomic, diatomic, or polyatomic is always equal to 3 by 2 kT. Lot of people are doing this mistakes. Okay, they consider here degree of freedom. If they are asking the average energy, always take 3 by 2 kT. Your reference is here. Don't use your extra brain. Okay, reference written here. You will take 3 by 2 kT. As temperature is same, so we can say energy will be same. Okay, is always equal to 3 by 2 kT. Depends only on the temperature and independent of the nature of gas. Remember, okay, this line here, if they're asking average, if they're asking total energy, consider degree of freedom. Total energy, consider degree of freedom. If they are asking average energy, 3 by 2 kT, and reference is your NCRT only. You will, okay, take the reference of this. Yes. Now, then they have written, since okay, argon and chlorine both have the same temperature, that's why energy will be what? 1:1. Then they're asking ratio of the speed. Ratio of the speed is nothing. You can calculate. Speed is nothing. This point is important, that 3 by 2 kT. Why important? Because people are taking here degree of freedom. Okay, here you cannot take the degree of freedom. Average energy, you have to take either any gas, monoatomic, organ, diatomic like chlorine, or any of the polyatomic. 3 by 2 kT you have to take. Okay, now they have given this thing, a cylinder of fixed capacity 44.8 liter at standard temperature pressure. At standard temperature pressure, 22.4 liter is the 1 mole. 1 mole, okay, 1 mole is the 22.4. It means this is how many moles? This one you can say directly 2 moles. Okay, 2 moles given. And they are saying what are the amount of heat raises to increase the temperature of the gas in the cylinder by 15 degrees Celsius. In the cylinder, like this is the cylinder, fixed capacity. If they are saying fixed capacity means what is constant? Volume constant. Fixed capacity means volume is constant here. Okay, volume constant. Fixed capacity, volume not changing. Okay, question is basic, but okay, because nothing is specified, so you think that what to take now? Constant volume, constant pressure. So fixed capacity, volume constant. So heat we can write here simply NCV delta T. Moles are here 2. Why moles are 2? Because we know 22.4 liter is the 1 mole, so 44.8 will be the 2 moles. Okay, so 2 CV, it is the helium, so we can write here 3R by 2. Delta T they have given by 15 degrees Celsius, to cancelled. This becomes 45R. Okay, R you can put dependent on whatever options are given, or in this one R they have given 8.3. You can put here 8.3. Yes. Okay. Now, at what temperature, this is the exercise question, at what temperature is the RMS of, okay, AR means VRMS of AR is equal to VRMS of helium, okay, VRMS of helium, okay. Now we can write here in this one root of 3RT1 by M1 equal to, we can write here root of 3RT2 by M2. Now we can do square both sides, so root we can remove, 3R we can cancel, T1 at what temperature, okay, they are asking the temperature of organs. We can say T1 we have to find. Mass of they have given here, that is a 39, you can take it 40, 39.9 is the 40 only. This T2 is given minus 20, but you cannot take minus 20 plus 273 you have to do, okay, because temperature you have to keep always in the Kelvin. So we can say this one becomes 253, okay. So you can say 253 divided by mass of this is 4. You can write this one becomes here 10. So T1 becomes here 2530 Kelvin, and you will get in the degree Celsius also. Okay, if they're asking the option in the degree Celsius, you can write in the degree Celsius. Okay, important question, good question. Okay, NCRT exercise type question, they might change a little bit, but or they can ask similar to that also. Yes. Okay, finished. Now Now coming for the next chapter, which is the oscillation. Okay. In this one we got here. Okay. Because in 11th a lot of things are there. In the 12th mainly optics is there, and wave optics and semiconductor. Because atom and photoelectric effect are the easy chapter, means small chapters. Here these are the somewhat lengthy chapters, and weightage also more. Okay. In the Now, first question coming from the oscillation is this is the first example. Average human beats 75 times in minute in frequency. So you can say 75 by 60. This is your frequency, which will become 1.25. Okay. If you need time period, then simply you can say 1 by f will be the time period. Okay. Basic question, very basic. Okay. But given, so you have to know this one. Okay. Because per minute given, that's why you have to divide with the 60. Okay. Now, second question is here: which of the following functions are representing your periodic and non-periodic? Okay, and you have to say the period. Listen, here I will modify this question. I will tell about the which of the following are SHM. Okay, because ultimately they are going to ask about the SHM. Okay, if I say these two functions, okay, these two are non-periodic. Okay, non-periodic. Okay, and these two are periodic. Okay, periodic. But I am asking about the SHM. Okay, SHM how to be periodic first of all. Okay, SHM how to be periodic first of all. I am writing the condition. For the SHM, you will take sine and cos only. Sine and cos only you will take in the SHM, because they will ask question for the SHM. Okay, if they are asking periodic, non-periodic, then trigonometric functions are periodic function. Okay, exponential, log, they don't repeat, they are the non-periodic. Okay, simple. Exponential, log are non-periodic, trigonometric functions are periodic. Okay, now sine and cos, but I am telling the condition of SHM, sine and cos only. Number two, amplitude must be constant. Okay, amplitude constant. And number three, if more than one term, okay, then all must have same frequency. All must have same frequency. Okay, all must have same frequency. These three rules you will use. You will without any mathematical, you will get the answer which will be SHM, which will not be SHM. Now, if I say this one can be SHM, no. This one can be SHM, no. Okay, I'm checking for the SHM. Log cannot be the SHM. This also cannot be SHM. These two are the periodic. We'll check. Here frequency is omega. Here frequency 2 omega. Here frequency 4 omega. And what I'm saying, rule number 3 saying, if more than one term is there, if more than one term, then all must have same frequency. So second can be SHM here. Second cannot be SHM. It is a periodic, but not SHM, because frequency not same. Frequency how to be same. So here omega 2 omega, it is periodic. Okay, means we can say second, okay, third and fourth, non-periodic and non-SHM. Second is periodic but not SHM. Why not SHM? Reason is this: omega here, 2 omega here, 4 omega. That's why not SHM. And if I say first one is the periodic also and SHM. Why? Because here your omega and here also omega. Frequency is the same. That's why it is SHM. Okay. So third and fourth are non-periodic. Non-periodic means non-SHM always. Second is the periodic but not SHM, because frequency different, omega 2 omega and 4 omega. And first one is what? Periodic as well as SHM. Okay. So remember this point here. Now, this is the question coming from the reference circle. Always important questions. They are saying in this one, I will say both the questions. Figure given below depict the two circular motion. Radius is given. Obtain simple harmonic motion of the x projection. X projection means you will draw line on the x. Okay, listen. If I talk about this one, this is the very easy. I will draw a line on the x. This is the t equal to 0 here. So if I draw the projection of this one, then we can say particle is here going like this. Particle at the mean position and going like this. Okay, positive side. Particle at the mean position. Equation is always sine omega t. So I can say for this one it becomes a sine omega t. Okay, particle is at the mean position and moving in the positive side, that's why a sine omega t. If particle is suppose here at the extreme, then you will take cos. Negative extreme, you will take minus cos. And if particle is suppose going negative side, you will write here minus sine. Okay, so a sine omega t. A, you can put the data whatever is given here in this one. Okay, a and sine omega becomes in this one your 2 pi by t 30 into t. Okay, so done here. Okay, particle is at the mean position moving in the positive side, that's why we are in a sine omega t. If you take this one, then we can write right now particle is where? Okay, t equal to 0, particle is here, particle is going like this, going like this. Okay, so particle is actually here and particle is coming this way. I will make the bigger diagram of this because diagram is somewhat small. Okay, they are saying here in this one, particle is right now here. Okay, this angle is 45, t equal to 0, and particle going like this. See, everyone knows in the t time particle will travel some angle omega t. Particle will rotate by angle omega t. Okay, in the t time particle will rotate by angle omega t. You know this is 45, this will be also 45, but in the t time particle will reach here. Okay, in the time t, and this angle will be omega t. This total was 45, है this one is omega t. I will use this triangle. If you can see this one green one, I will draw here. Okay, because I know this one is my x and this one is my y. They can ask anything. What will be this angle? You know this total was, okay, if I say this was the your this is the 45. If this is the 45, remaining also 45. So this angle I am asking. So you can say this will be 100% 45 minus omega t. This must be 45 minus omega t. Then you can use sine theta or cos theta. So if I use sine 45 minus omega t, it will be equal to x by a. If I use cos 45 minus omega t, it will be equal to, now we are taking this one, and this one you will write here y by a. So you got equation of x also and equation of y also. Only thing what you have to find, angle you have to find. Okay, again I will say the angle things again. Okay, I'm going to draw here because main point is the angle only. We can say like this, it is t equal to 0, this angle is here 45. So you can say this is also 45. Okay, in the t time it moved here, we can write, okay, it moved here, and how much it moved? Omega t. So I'm saying this angle and this angle will be what? 45 minus omega t. Okay, once you got this thing, you can easily solve these questions. Angle is the most important thing in these type of questions. Now, and if they are going to ask, they will ask actually this one. Okay, this one, this is the much easier because here you don't have to find the angle. They will give always these positions. This is the mean. If they are giving here, then extreme. If they are giving again here, this is the mean. They are giving here, this is the extreme. So these four positions are most probable position. Okay, and easiest position also. Okay, this one is the mean. This is also mean, but here mean positive, here mean negative. Here it is the positive extreme. Here your negative extreme. Here equation will be plus sign, here plus cos, here minus sign, here minus cos. At least those four positions you can remember. Now, a body oscillate with the SHM according to the equation x equal to 5 cos 2 pi t plus pi by 4. Okay. Now, in this one, they are asking calculate the displacement, your okay, speed and acceleration. You have to only calculate displacement using this equation. Once you get the displacement, okay, Ready? Okay. Now, so we can say wherever these equation-based questions are coming, like in this one, they are asking your displacement, velocity, and acceleration. So displacement only you have to calculate. You will put the data here, and speed you will use this formula. Acceleration you have to use this formula. So if you put here in this one time, okay, that is they are asking at 1.5. So we can say 5, okay. Here cos 3 pi plus pi by 4, and I think 3 pi plus pi by 4 you can easily do this calculation. It will be the 2 pi, you can subtract pi plus pi by 4. Maybe they can give easy data also. This is the your calculation. Okay, I think ASTC you can use pi plus pi by 4. Okay, 3 pi, 2 pi you can remove na. It will become how much? Cos pi plus pi by 4. Cos pi plus pi by 4 is minus cos pi by 4, and cos pi by 4 is how much? Minus 1 by root 2. Okay, so that value you can put minus 1 by root 2. It will be coming this result. But x you have to find for the velocity. Okay, you will just use not this way. Okay, don't do like this, don't do like this. Simply use the formula omega root a square minus a square, and acceleration also minus omega square x. Now, this is given here, two identical springs of spring constant K are attached, okay, and they are asking that, find time period of oscillation. We know this case is series or parallel. Whenever block is in the middle, okay, it is always parallel, okay, and if it is the parallel, then K equivalent will be always given by K1 plus K2. It means in this case it becomes 2K, okay. In the parallel, okay, whenever block is in the middle, it will be the parallel, and K equivalent will be given by K1 plus K2. That's why K plus K becomes 2K, and time period you can write here 2 pi root of m by 2K. Okay, time period is simply equal to 2 pi root. Okay, time period is 2 pi root m by 2K, because equivalent, okay, K is what? 2K. Okay, so one easy question but important. Okay, very easy, was just one liner question. Okay, languages you can say the same language they will give. Diagram also will be given to you. These are the two graphs always you have to remember: kinetic energy and potential energy. If I say this one here, this graph is your potential energy graph, this pink one. Okay, pink graph you have to remember. Pink graph is for the potential energy, and here, okay, this one inverted one, because where potential is maximum, K will be the least. So this green one, inverted one, is the opposite one is the graph of kinetic energy. Total energy will be always constant. This black one is the total energy, always constant. Okay, and same we can say here also. If you see this black one, okay, you see the black one. This black one is the okay. Now here these graphs can change, okay, slightly, because it depends, okay, that particle is starting from mean or extreme. So these are not fixed graph. Okay, they can interchange. This can be the potential, this can be the kinetic, or this can be the kinetic, this can be the potential, but this one is always fixed. Okay, so that's why here interchange possible. Here it will not be changed. You have to remember that always potential will be like this, kinetic will be always inverted one. Okay, these might change. Okay, dependent on the function, this can change, this will remain always fixed. Okay, so this graph should be there in the mind. Now they have given a block whose mass is 1 kg is attached to this spring, and spring has a spring constant. Using this information, what we can find first of all is the omega. We can say your omega is equal to root of K by m. Okay, K in this case is given 50, mass is given m, so this becomes root 50. Root 50 is almost 7, I can say. We got the omega 7. Block is pulled to the distance 10 centimeter from the equilibrium. Okay, like this. Okay, block you are pulling, this is the equilibrium. You have kept to the 10 centimeter pulled. Okay, here. Okay, 10 centimeter, and then they are saying it is released. Calculate the kinetic potential and total energy of the block when it is a 5 centimeter away from the mean position. So you can say in this case, this amplitude becomes the 10 centimeter. Okay, potential energy we get half of kx square. half k will be m omega square x square. You can put the data here. Half mass in this one is 1 omega square will be 50, okay, because root 50 was there. X square will be the 25 centimeters, so 10 power minus 2. This is the potential energy, okay. We got the potential energy, quiet energy, half k x square, half k is the m omega square x square. They are asking what will be the kinetic. For this one, I will find first of all total energy, half Ka square. Same way, everything is same, half, okay, half K will be equal to m omega square. So m omega square 50. But here amplitude is 10 into 10 power minus. If they are asking your K, then K will be equal to always total minus potential, okay. And you got the total, you got the potential, you can easily calculate the total. This question will not count as the tough question, it is the easy question, not calculated also, because calculation also very easy. You can see this one, you can write here 25 is how much? 625, okay. If I have to calculate now, 625, okay, so this becomes 6.25, okay. So calculation also very easy here in this one, okay. So for the energy graph and then this question, okay, these two things are given in the NCERT, graph given and NCERT, okay. Then this question is from the simple pendulum. If you see, what are the length of simple pendulum which ticks second? It means they are talking about the second pendulum, and you know time period of second pendulum, okay, is 2 seconds, okay. Here see the time period, okay, of simple pendulum which ticks second is 2 seconds, okay. So we can write here t equal to 2 pi root L by g. This one is given 2 seconds, 2 will be cancelled, so pi square L by g equal to 1. G and pi square almost same, so length becomes 1 meter. So you will remember that this pendulum is known as your seconds pendulum, and for the seconds pendulum, length is 1 meter at the surface of earth, and your time period is 2 seconds. Seconds pendulum don't have time period. Once again, a lot of people are getting confused. They say, oh, given here in this one that tick seconds, okay, like this one, which ticks seconds. Which ticks seconds does not mean 1 second, okay. Time period is how much? 2 seconds. Clear? This is the seconds pendulum. Time period is 2 seconds. Don't do that mistake, okay. A lot of people solving by taking 1. Now, this is the question taken from the exemplar, not exemplar, I think this is the maybe exemplar or exercise, I don't remember exactly. They are asking which, okay, is the simple harmonic motion. You know, simple harmonic motion has this relation. A equal to minus omega square x means A proportional to minus x. Then only this is the SHM. A proportional to minus x should be there. Then only this can be the SHM. Otherwise, this cannot be the SHM. A how to be proportional to minus x. A should be proportional to minus x. This one no, this one no, because here no negative, here x square no, this is x cube no. Only this answer is possible. Yes, clear? Like this, if questions they are giving, okay, I hope we can do easily, na? And like this only questions will be given, okay. You will see so many questions, okay, will be seen to you in our examination. Now, this is the question from exemplar, one good question, okay. We have asked multiple time in the exam also. They are saying that okay, when two springs individually S1 and S2, frequencies are V1 and V2 or nu1, nu2, whatever they are saying. Then in this case, what will be the frequency? Everyone knows this is the parallel, and the parallel K equivalent is simply equal to your K1 plus K2, okay. See this one, very important. Yes, for this year, K equivalent equal to K1 plus K2, okay. You need to replace in terms of frequency. You know that here, okay, if I write T is equal to how much? 2 pi root M by K, it means frequency is what? 1 by 2 pi root K by M. Means frequency is proportional to root K. From here I can write frequency proportional to root K. It means frequency square is proportional to K, this relation, okay. frequency proportional to, okay, frequency square proportional to k. You know, time period is 2 pi root m by k, so frequency will be 1 by 2 pi root okay, k by m 1 by t. So frequency proportional to root k, that's why, okay, frequency square proportional to k. I can write here in this one that nu equivalent square equal to nu1 square plus nu2 square. So we can say nu equivalent frequency will be given by root of nu1 square plus nu2 square. Okay, you have to remember this one, you can write. Okay, take some time in this question. Okay, this question can be asked for the time period, either for the frequency. Okay, both important, either time period, either frequency. Okay, anyone having any doubt, you can ask quickly. Yes. Now I will go for the next one. This result also you have to keep in the mind in terms of frequency and time period both. Okay, now then coming for the wave. Okay, in the wave, if I say, then okay, first question is given about the type of wave. They are saying motion of kink in the longitudinal spring by displacing. If you take this spring and you are displacing like this, okay, then it is moving this way, so it is a transverse. But in the spring, this type of movement is also there. In the spring, okay, if a spring is there now, whenever you will move like this, so this will be the transverse as well as these different parts, because spring is flexible, so they will be moving like this. So we can say in this one, in the first one, okay, when you are moving, it will be both longi plus trans, both waves are there. Okay, mostly people say that if this is the, okay, moving like this means this is the transverse. If it is the string, it is the transverse. Spring is flexible, that's why this type of movement will be there, that's why transverse and longitudinal both will be there. Waves produced in a cylinder containing liquid by moving its piston like this. Then we can say if you are moving like this, then in this case wave is only going to be longi here, so we can say this will be the longitudinal. Waves produced by motor boat, you have seen in the class also that wave produced by motor boat on the surface of water, both waves are possible. It is the longi plus trans. Okay, longi plus trans, both possible on the surface of water. Okay, they are saying ultrasonic wave, okay, produced by the ultrasonic sound wave. Sound wave is always longitudinal. Okay, sound is always longitudinal. Only this spring case people are doing the mistake. They think, oh, we are moving like this. Moving like this means this will be the what? A spring, you are moving like this, na? The transverse. But in the spring, different parts also will move closer and away. Compression, rarefaction happens. String only transverse, but spring both are there. Okay, and waves on surface of water both are there. Longi plus trans. Ultrasonic means sound wave. Sound wave are always longitudinal. Okay. Now, they have given in this question, steel wire is given and wire, okay, what are the speed? You know, for the speed, you have to remember this formula, V equal to root of T by mu. T is given, very basic question here. T is 60 and mu, okay. Mu is not given. Mu you have to find. Mu is the mass per unit length. So we can say mass per unit length, we can write here 5 into 10 power minus 3 divided by your length 0.72, okay. They have calculated, so I'm using the same data, 6.9 into 10 power minus 3. So I can put here 6.9 into 10 power minus 3. Maybe in the exam they can give slightly easy data, okay, because you know some tough calculation you may not be able to do, so they will give slightly easy data. Approximation will work. You will always work on the likes. 6.9 you will assume as 7 approximation, okay, you can use. Okay, just you have to check the options. If options are very close, don't go for the options. Means your approximation. Options not close, go freely with the approximation. They are not going to check your okay, calculative skills. They just want to check your analytical skill. Okay, that is needed. Next question is from the your okay, pipe. Very good question. In the wave they have given very less salt example. Earlier a lot of salt examples were there. Now they have removed. Okay, so this one is given. Okay, I have given solution also for this, but I will solve. They are saying that pipe is there, is open at both ends. You know its fundamental frequency will be what? V by 2L. Pipe open at both ends, fundamental is simply V by 2L. Okay. What are the V given here in this one? That is the 330 divided by 2. Length is given 30 centimeters. So we can write here 30 centimeters by 100. Okay. It's a 0, 0 cancel. This becomes here 11. Okay. So this becomes 5.5. Okay. 5.5 into 100. I can write like this also. Now, I can write 0.55 into, okay, like this also, okay, 10 power 3. So that becomes point, okay, 55, okay, kilohertz. And they are saying that we are having 1.1 kilohertz, okay. So you know that, okay, either you can write this way also that this is a sir 550 and better, okay, like this, okay. This is the 550, why to confuse you. This is the 550 frequency, fundamentally the 550, and they are talking about a 1.1 kilohertz. 1.1 kilohertz means what? 1100 hertz. So with respect to this is how many times? Fundamental is 550. Fundamental is how much? 550. How we calculate? V by 2L. V by 2L fundamental becomes 550. But they are asking that, okay, which harmonic mode is this? Which harmonic mode is 1100? We can say which harmonic mode is 1100? 2 times. 2 times means which harmonic? Second harmonic. Okay. 2 times means it is the second harmonic. Clear? Fundamental is 550. They are asking that 1100 is what harmonic? We can say 1100 is the twice of this, and twice of this will be what? Second harmonic. Okay. So it is the second harmonic. Now, this is the question from the beat, single question given in the beat, only one question. Okay. Chances are also that they will ask the same question. They are saying in this one, beats you will use that method, whatever you have done. Either you can go with the option checking. I'm saying one method, 2 sitar strings A and B playing, this is the A, this is the B, are having 5 beats, and okay, A frequency given, frequency of A is 427. This is the A. A is 427, then we can say B can be what? B can be either 5 more or 5 less. So this can be 432, either 422. Okay. A is 427, then okay, B can be 5 more or 5 less, either 432, either 422. Then if you read that if tension in the B is slightly increased, okay, tension in this B is slightly increased, you know that N is proportional to root T. If you increase the tension, this frequency increases. If this is the, this will increase. And if this increases here, beats will keep on increasing. Beats, okay, but like this will increase now. 432 will become what? 433, 434, 435. So this difference will increase, but this will become what? 423, 424, 425. Okay, so they are saying beat frequency is 3 hertz. So beat frequency 3 hertz possible with the 432? You can say not possible with the 432, because with the 432 always keep on increasing. With respect to 432, it will always keep on increasing. But yes, 422 it is possible, because when 422 okay will increase, it will become 423. Then how many? 4 beats. Then here 3 beats. Okay, here 5, here 4, here 3. So here possible. So what is the answer possible here? 4, okay, 22. Clear? So B can be 422. Practice this question, single question given, okay, important. They have asked also previously this same. Maybe again they can ask this. Now, this is the question taken from the exemplar, okay, and they are saying in this one, equation of plane progressive wave, slightly tough, because generally I feel that reflection may not be coming, because some mathematics is there, but here little mathematics is there, not too much. They are saying that y equal to, this is the equation, or reflection from the denser medium. First of all, whenever denser medium is, there will be the pi phase change. Okay, you have to remember this thing. Denser medium is pi phase change. Okay, will be there. Denser medium is pi phase change will be there. Okay, and amplitude becomes 2 by 3. So we can say amplitude 2 by 3. Let's solve. So y equal to, we can write 2 by 3 of 0.6, sine will remain sine 2 pi t, this x will become -x, so t plus x by 2 plus pi. This is the answer. Okay, like this we solve. Okay, 2 by 3 becomes amplitude, 2 by 3 into 0.6 into sine 2 pi, here t plus x by 2 plus pi. Pi plus theta always, pi plus theta is always minus sine theta. This one you will say 0.2, so this becomes okay 0.4. Okay, so 0.4 into sine 2 pi, but here you see pi plus theta will be minus, so this minus will come outside, so it becomes t plus x by 2. Okay, this is the answer. Okay, clear? Possible or not possible? Okay, I will tell now one more method, okay, because this is slightly mathematical. People may not get this answer. So option checking, okay, will work. Okay, how option? This is the actual method I said. Okay, how we'll do the option checking? I will tell now option checking method. First of all, you know that wave how to move in the opposite direction. Okay, first you will say amplitude 2 by 3. Amplitude 2 by 3 means 0.6 into 2 by 3. It how to be 0.4. 0.4. This one is not there, so this one not possible. Now three options there. Okay, so we can first option discarded. Then it how to move in the opposite direction. So t minus x by 2 means it should be t, okay, plus x by 2. So either, okay, this one not possible. D also discarded. Okay, now what is left? Two are left. Okay, either this one, either this one. Okay, now in this one you will put x equal to 0. Okay, put, okay, x equal to 0. In this one if you put x equal to 0, okay, then you will get 0.6 sine 2 pi t, and if you put here x equal to 0 in this one, okay, then minus 0.4 sine 2 pi t, and in this one you will put 0.4 sine 2 pi t. Okay, now x equal to 0 I am putting, I got. You know that in the rigid node or anti-node, in the rigid node is there. Node means minimum or maximum. Node means minimum. Minimum means they have to cancel each other, na? They have to cancel a minus a. That's why it is the node. In the antinode, what becomes? A plus a becomes 2a. So now you will add, either this will be added with this one. So if you add this one with this, then you can say this okay, function plus this function, yes, value will become less. Here value decreasing. But if you are adding this function, then value is what? Increasing. Means this answer will be possible for which one? Here increasing, it will be possible for the antinode. Antinode means free end, and this will be here value decreasing, means this is only possible for the your rigid end. Okay, so rigid end answer will be only this. This will be only possible for the free. If free the given, then we can write this one. Yes, for the free, because here increasing means free, decreasing means rigid. Okay, because rigid node will be there. Node is the minimum displacement, anti-node is the maximum displacement. You can check the option like this. Okay, this is the one method. Second question, taking again from the exemplar here, they are saying a string, okay, is under this tension and length is given, and how much time it will take. So you can see here tension is given. So first of all we have to find the velocity. Okay, I will use say just here. So we can say velocity formula is root of t by mu, and in this case mu we have to calculate. They have given 2.5 kg, length is 20 meter. So this is the mu we are getting. Okay, t by mu is e. Okay, mu equal to mass by length. Okay, and then we'll calculate the speed equal to t by mu. So 200 divided by 0.125, this becomes root 1600, means how much? 40 meter per second. Okay, first we are calculating the root of t by mu, and mu we don't have, so we can find, okay, t is how much here? Your 200. Mu is m by l. M is how much here? 2.5. L is how much in this case? Your 20 meter. And now we can okay, get this calculation. If you are putting here, we are getting this answer as 40 meter per second. Okay, they are asking time. So yes, time is always equal to your length divided by speed. Length is how much here? Your 20 meter. Speed is coming how much? 40. Answer becomes half. Answer will be half second. Solution is given. Okay, you will check one time this question. Okay, question from the exemplar directly they can ask. Okay, because now then we are having here ray optics and optical instruments. Okay, now in this one, first question is coming here. Okay, because they have not given the plane mirror, they directly started with the spherical mirror. They are saying suppose that lower half of the concave mirror like this. Okay, lower half of the concave mirror. Okay, in this one, if we cover this lower half, okay, this part is covered. Okay, this one if you cover, okay, with the non-reflective material, okay, what effect will this have on the image? Listen, if you cover this part, then upper part will make the image. Okay, nothing will happen to the image, only brightness of image will be reduced. Image will be formed as it is, only brightness of image will be reduced. Even though this small part, you cover whole mirror, only this small part is there, image will be formed. Image may not be bright, okay, because a lot of intensity you have blocked, a lot of okay, light you have blocked, so image may not be that much bright, but image will be formed. Even though small is, each part of the mirror or each part of the lens will make the image. Okay, so parameters of image not change, yes, intensity of image will be changed. You will read here, you may think that image will now show only half of the object, full image will be formed always. Okay, but taking the laws of reflection to be true for all the points of remaining part of the mirror, image will be that of the whole object. However, as the area is reduced, the intensity of image will be low in this case. Same in the lens also, they will say like this, that we have, okay, covered, okay, this much part we have covered. If you cover this much part, okay, then nothing will happen, image will be formed at the same position, at the same thing. Okay, only what will be happen, intensity will be reduced, either lens is there, either mirror is there. Okay, image will be formed full only. Okay, what will happen, intensity will be reduced. This is the second question here. They are saying in this one you have to find the position of image, and this one we will use the mirror formula here. Like we can use 1 by v minus means plus 1 by u equal to 1 by f. One I will solve, other you can do. Okay, they are saying object is placed. Okay, radius of curvature is given here 15 centimeter. You know, radius given 15 centimeter, it means focal length will be how much, r by 2, which becomes here 15 by 2. Concave given, that's why I will write minus. First one they are saying 10 centimeter, second they are saying 5 centimeter. So I can say 1 by v, and listen, u, real object u is always negative. Real object u is always negative. If you have doubt, and if you can see the object, if they have given the object, it means it is a real object. Okay, so you will take always negative. Okay, because virtual object is one concept we use. So because of that one thing, you cannot be confused all the time. Take your u negative. If they have given object is here, it means it is the real object, take as negative. Okay, so minus, we can write here 10 because the 10 centimeter I'm solving for this one, equal to, we can write focal length, so this becomes minus 2 by 15. Okay, 1 by f. Okay, so we can say 1 by v will be equal to minus 2 by 15 plus 1 by 10. 15 and 10 LCM is 30, so this becomes 2 minus 4 plus 3, this becomes minus 1 by 30, and v equal to becomes minus 30. Okay, you can solve like this. I hope you can do. V equal to minus 30, then they are asking magnification, and we know magnification is nothing but the minus of v by u. So we can say minus plus 30, and you will take negative, so we can write here minus 10, m becomes minus 3. Magnification minus 3 means simply it is the image is bigger, but minus indicates inverted. Okay, so image, and whenever you are inverted, it is the real. Okay, so image is the magnified, real, and inverted. Okay, like this characteristic they can ask. You will try for the 5 centimeter. I have solved for the 10. Next you have to solve for the 5. Okay, now they are saying in this one, suppose while sitting in a parked car, you notice a jogger approaching towards you in the side view mirror of r equal to 2. Okay, In this one NCRT solved example, they have taken the average velocity method, and they are saying average speed equal to instantaneous speed, which is not always correct. If time interval is very small, then only we can say instantaneous and average to be same. Okay, maybe they didn't wanted to use the differentiation method, that's why they have used the average method. But you will use formula whatever is told to you in the class. You know, formula told to you is this: velocity of image with respect to, okay, mirror equal to minus m square velocity of object with respect to mirror. M we write f by f minus u, so this becomes f divided by f minus u whole square velocity of object with respect to mirror. You will use this formula whenever asked. This gives the instantaneous value. Now I will use here focal length is radius given, okay, so radius 2 meter, okay, so we can say focal length will be equal to 1 meter, and this one is okay, side view mirror is always convex, so we can say this one with the plus, so we can write minus, it is the, okay, 1 divided by, I can write here 1, because they are saying this is the 39 meters. So I will solve for the 39. Okay, so u equal to minus 39. So 1 minus minus becomes plus 39 whole square into this is 5. Okay, so you can say this becomes minus 1 by 40. So 1 by 40 into 5 meter per second. Use formula always, this formula. Okay, because NCRT not using that is there, okay, maybe they didn't want it to use the differentiation, but you can use this one because average is not always equal to instantaneous. Only for the whenever that interval we consider to be very small, then only average and instantaneous you can take same. So go with the formula. This is the formula. I hope everyone knows. Vi with respect to mirror equal to minus m square velocity of object with respect to mirror minus f by f minus u. Magnification always you have to keep this formula in the mind. F by f minus u. Magnification always f by f minus u. Okay. Now there is the one note. A lot of people are getting this confusion. Okay, because in the middle one answer was wrong. Okay, so I have taken this one. Optical density should not be confused with the mass density. Mass density is the mass by volume. Okay, and optical density represents the refractive index. Okay, optical density represents the refractive index. Optical density, if you see, it is the ratio of speed of light into medium. Means this is the your C by V. This is the optical density. You can say optical density, or we can say your refractive index or refractive index. Okay, and they are saying for example, okay, they have taken this one. Mass density of turpentine is less than that of water, but optical density is higher. Okay, so both are not same. Okay, they are different. Optical density refers to the your refractive index. Mass density is simple. Okay, mass density means mass by volume. Okay, now there is the only one question in whole NCRT for the spherical refraction. And spherical refraction is quite okay. I was expecting last year that this will ask spherical refraction. They are not asked. In the JMIN, continuously they are asking the spherical refraction. Sometimes what happens, whatever asking there, they can repeat. And single question, it means probability will be the same question they can ask here. Read the question, then I will explain. They are saying in this one, light from a point source falls on a spherical glass surface. Like this is the spherical, I can say. This is the spherical glass surface. Light from this point source, this is the point source, okay, falls on this one. They have given radius of curvature to be 20 centimeter, okay, and they have given the distance of a light source is 100. Okay, very important question. Okay, at least for this year, because I was expecting this question to be asked last year. Okay, maybe you will see this question this year. Okay, lot of questions will be from this file. Okay, it means after the Neet I will display this one, that yes, this question came, this question came. Now we can say that they are asking where image will be formed. For this one, formula is here. I am writing mu2 by v minus mu1 by u equal to mu2 minus mu1 by r. Okay, this is the formula we'll use. And now, what are this direction is going to be positive here. So you can say this u is going to be negative, okay, because this side positive, this is negative. R is going to be positive here. Mu1, if I say, then this is the outside one, and mu2 is inside, so 1.5, okay, or I can say 3 by 2 or 1.5, whatever. I hope up to this is clear. Question given, so diagram I am making, object is outside at the 100 centimeters, so u is minus 100. This side radius is plus, this index is 3 by 2 because glass here 1, okay. Let's put the data in this one. I am putting here mu2 means your 3 by 2 v minus mu1, which is the 1, divided by u minus plus equal to mu2 minus mu1 3 by 2 minus 1, which is the half, into r, which is the 20 here, okay. So 3 by 2v equal to 1 by 40 minus 1 by 100. Now we can say 1 by 40 minus 1 by 100. This becomes how much here? 200. This one becomes 5 minus 2. So 3 by 2v equal to 3 by 200. 3 cancel, you got v equal to 100, okay. So remember, in this one, image is formed at the 100 centimeter, okay. And plus 100 means that side, okay. Image is found at the distance of 100 centimeter from the glass surface in the direction of incident light. Maybe somewhere ray will be coming like this, and ray will, okay, image will be formed somewhere here, okay. Here image is formed, okay. Solve this question again, okay. Or solve one time, you will solve this, okay. Solution, no problem, because suppose if you're not, okay, first of all, you can write, you can copy, you're not copying, you can search, okay, easily all the NCERT solution you will find, okay. That is not the, okay, already solution written also, na? Now, this is the one question. If f equal to 0.5 meter for a glass lens, okay, focal length is given here 0.5 meter, okay. They're asking what is the power. First one is the power. Power is always equal to 1 by f. They say power will be 1 by f, you put, that will be the 2 diopter, okay. Radius of curvature of the face of double convex lens are 10 and 5 centimeter, okay. Its focal length is, this is the second question, okay. They are saying in this one, okay, this example itself is important because in this one they are trying to cover 3 questions. These 3 questions are not related, separate questions, okay. They are written in the your 9.7 only, but it is the your 3 questions, all separate, okay. They are saying this one is the 10 centimeter, this one is the 15 centimeter, and focal length is 12 centimeter. Mu you have to find. We'll use lens maker formula 1 by f equal to, okay, here mu by 1 minus 1 because outside here, so 1 by, okay. Here we write 1 by r1. You know that this is the light coming, r1 becomes this, r1 is positive, this one will be, okay, r2 will be negative. So we can write here in this one 1 by 10 minus plus 1 by 15. Remember, when you are solving for the convex, it will be, both will be positive. F I can write here 1 by 12, okay, this one we have to solve. So 1 by 12 equal to here mu minus 1, 1 by 10, 1 by 12 means this 15, 30 is the LCM here, so 3 and 2, 5. This one you can say this becomes a 6, this will be 2, so mu minus 1 equal to 1 by 2, mu equal to becomes 3 by 2, okay. Yes, this is the, okay, second one solved here, okay. This gives mu equal to 1.5, okay. Important question, good question, take some time, okay. And then in the third part, third is also separate question, okay. They are saying in the third part, a convex lens is 20 centimeter in the air. What is the focal length in the water, okay. Focal length in the water, okay. First you can see, then I will erase and I will solve that third part, okay. Now, in this one we can say in the air, okay, so we can write 1 by f equal to here 3 by 2 into 1, okay, minus 1 into c, because we are changing the medium. Third question is about change of medium. change of medium. Okay, medium we are changing. So we can say 3 by 2 minus 1 into C. This is given 20. So we can write 1 by 20 equal to C. So from here you can say C becomes 1 by 10. Now we are keeping this in the water. Okay, so in the water we can write focal length. We have to find 1 by F in the water equal to 3 by 2. Water index is 4 by 3 minus 1 into C. Here I will put the value of C. Okay, they have taken 1.33. I am going to take 4 by 3. Okay, this much freedom you can also take 1. Why to take 1.33? Okay, always prefer calculation in the fractions, not in the decimal mistakes may happen. Okay, so you can say 1 by FW becomes here, okay, 9 by 8 minus 1 means which is the 1 by 8 into C is the 1 by 10. It becomes 1 by 80. Okay, so focal length in the water becomes 80 centimeter. These two questions, whatever I have solved, 100% will be in your notes also. This is the PYQ question also. You have solved earlier. We have asked so many times in the examination, and again, always important. Okay, clear? They got 78.2, but okay, because we have taken 4 by 3, that's why 80 we got. Over. Yes. Practice again. Okay. Now, this is the one question here, and okay, good question. Appears like it will be the very typical question, but if you see here, find the position of, okay, image formed by the lens combination. 3 lenses given. Okay, so you can say first one, object is at 30 centimeter, and this will make the image. This focal length is 10. So we will write here in this one that 1 by V1 means image 1. Okay, minus minus I can write plus 1 by 30, because here you will be, okay, you will take u as minus 30, minus minus plus equal to 1 by 10. So 1 by V1 will be equal to 1 by 10 minus 1 by 30. You will say 30 is the LCM here, 3 minus 1. So you can say V1 coming 15. Okay, V1 coming 15, which is solved also here. Okay, here solved, I have solved again. Means now from this lens, it will be coming at the 15 centimeter. Okay, rays will go like this. Rays will be going, okay, like this, and then they will, okay, here. Okay, but what will happen when ray will go like this? They will meet this second lens. This part will never. That's why I have drawn what dot. Ray will, okay, just when reaching here, okay, what will happen? This will diverge. Okay, so now this point will act like the virtual object. This is the virtual object concept. Okay, so we can say rays never reach there. So this point will act like the virtual object. So you will read here, image formed by the first lens serve as the object for the second. This is at the distance how much? Total was how much? Here to here, total we got how much? 15 we got as per the calculation. But this one is how much? 5. So this will left how much? 10 left. Okay, so 15 minus 5 is 10 centimeter to the right of the second lens. Okay, through the image is real, it serves as the virtual object, because this point never formed. As ray will reach here, what will happen? Refraction will happen by the second lens. This point never formed, and which never formed will be considered as virtual object. Again, I am saying that okay, this question you need some attempts. Okay, I am explaining one time. You will try this question one time, and if you have doubt in this one, you will, okay, discuss with your teachers one time. Okay, because what happens, I'm saying maybe somewhere again you can miss a small time. Here you will get easily. Okay, oh, this is there. Okay, quickly you will get. Okay, after okay, by the evening, okay, somewhere, okay, we'll ask this question. So either practice 2 times this one. So written here, we got image here, but this ray never reached. That's why it is working like the virtual object. So from here, how much is the distance? You can say 10. So we can write here, u will be equal to plus 10. Virtual object, always you will take plus 10. Okay, it serves as the virtual object for the second lens. Okay, so now we'll write here 1 by V2, okay, minus 1 by 10 equal to here minus 1 by 10. This cancelled. V2 becomes infinity, means this lens will diverge such a way that ray will go like this. And if ray going like this, okay, then you know that image will be 100% formed at what? Parallel ray will always form at the 30, because this is the, okay. So now we can say V2 equal to infinity. For third lens, we can say for third lens, U will be infinity, okay, because it will appear rays coming from the infinity. So we can say 1 by V3 minus 1 by infinity equal to 1 by F3. F3 is the 30. So V3 becomes in this one 30 centimeter, okay. Again, it needs some patience, this question. That's why I don't think that everyone have done this question earlier, okay. Some people do, some people see the question, they ignore the question. Again, I am saying object is here. First, we'll make the image at the 15 centimeter image here. But okay, as ray will reach here, it will refract because it can never, okay, it cannot reach here. This point will act like the virtual object. We can see how much is the distance. We can say 10, virtual object will take as plus. So when we are calculating for the image by second, V2 equal to infinity. Okay, V2 equal to infinity means for the third lens, we can say rays are parallel. Parallel rays always meet at the focus directly. You can say answer like this, that this will be what? 30 centimeter directly. Okay, no need of this calculation also. So this question comparatively very easy. Only two calculation you have to do. Okay. And see, don't ignore this question. Okay, again I'm saying, because I know that okay, one or two time not coming, you generally ignore. Okay. They are saying now about the microscope and telescope here to achieve the large magnification of a small object. Okay, objective and eyepiece should have a small focal length. Okay, because you know FO and FE is small, then only will get the more magnifying power. Okay, FO and FE must be less in the compound microscope. Okay, in the compound microscope, FO and FE both must be less. Okay, so clearly to achieve the large magnification of the small object, hence the name microscope, objective and eyepiece should have a small focal length. FO and FE both must be less. Okay, and okay, they are saying also large lens are required to make the L large. Okay. For example, okay, they have taken one question, FO equal to this taken, FE equal to this taken, and tube length is 20. They're asking magnifying power. Use this formula, no problem. Okay, if they are asking the question in your examination, in the your okay Neet, okay, Neet, maybe probably they will take the same data. It is not given in the solved example or exercise. Between the theory, they have okay. Sometimes questions are hidden between the theory. That is the question. Freely just use this one. L by FO, D by FE. L is 20. This is the 1, 25 by 2. We got answer 250. Okay. However, this is not 100% exact. Okay. If we go by the exact method, answer comes slightly different. But you will go like this. Okay. Because they have used our reference is the NCRT. Okay. So we can easily use this one. L by FO, D by FE. Here they have written one more thing. Various other factors such as illumination of the object contribute to the quality and visibility of the image. Okay. In modern microscope, this question, if you remember, okay, previously I have asked as the same line, okay, I given one of the question. In modern microscope, multi-component lens are used for both objective and eyepiece to improve image quality by minimizing various optical aberration, okay, to remove the defect. Two questions, okay, I gave one time, and in that one, answers were kept. Operator by mistake bold, okay, options, I mean correct answer was in bold given. That was the one question. I hope you remember. Okay, remember this line, that in the modern microscope we use multi-component lens. This multi-component lens, okay, are used. Okay, you have to keep this line, multi-component lenses are used. Okay, why it is used? To minimize various optical aberration. Region is this. Okay, for the assertion region, this thing can be there to minimize various optical aberrations. Okay, now this is the one question here. See, a very good question, simple question, straightforward theoretical question is this. Radius of curvature is this. Okay, and they are saying in this one plano convex lens. Okay, so this is the 20 centimeter. Okay, radius. Okay, anyway, its focal length will be equal to 2r, so focal length becomes how much? 40 centimeter. They are saying act as the convex lens. Listen, plano-convex is the plano-convex. You keep object any side, does not matter. You keep object this side, you keep object this side, does not matter. Okay, they are saying act as the convex lens only if object lie on the curved side. Act as the concave. Okay, if the no, it will answer is what? C. Act like convex lens. You keep object anywhere. If it is the convex, it is the convex. It will act like convex. It does not depend on the object position. So your answer is what? C. You will read this one, okay? Because people are, they say, oh, kept this side, then this is the your convex. Kept this side, then this is the plane. Okay, so lens cannot change its nature by keeping the object, because object you can keep anywhere. Nature of the lens will remain same. If the convex, it will remain convex. You keep object here, either you keep object here. Don't use extra brain. Okay. Now given here, astronomical telescope objective is focal length 20 centimeter, and this is the 2 centimeter. These questions are from exemplar. Okay, when they will ask, okay, maybe here they can ask what is incorrect, like because 3 are correct, no? They will how to make single correct. So we know that length is always equal to FO plus FE. So FO plus FE means your 20 meters. So 20 plus 0.2. Okay, correct, because this is the centimeter. Centimeter means 0.02. Okay, this one is correct. Magnification is FO by FE. So you will write here FO 20 divided by 0.0. Remember, this is the meter and this is the centimeter. We don't see units in the examination. Directly, blindly we go 20 by 2, 10. Okay, so see clearly. Okay, it's meter and centimeter. We can get, yes, this is also correct. This thing we know image is inverted. Okay, we know image is inverted. Then they have given fourth one. If you read, objective of larger aperture will increase the brightness. Objective of larger aperture increase the brightness. Up to this correct. Up to this it is correct. Objective of larger aperture will increase the brightness. Correct. Reduce chromatic aberration. Reduce chromatic aberration is correct or wrong? Reduce chromatic aberration is this statement is what? Wrong. It means full thing becomes what? Wrong. If something is wrong in the statement, it means full statement becomes what? Wrong. Okay. So it will not reduce the chromatic aberration. It will increase the brightness, but not reducing the chromatic aberration. Clear this question? Answer becomes ABC. Now, here we are having your wave optics. In the wave optics, this is the first diagram given. That is your wave front type in the okay. So remember this diagram, very simple one. I will till now. They are saying plane wavefront will pass through this prism. You know, rays will come and after this ray will go here. This ray will go here. So we can say we are going to get this type of okay wavefront. If the same wavefront is okay coming on this one, then your ray coming like this, and here ray will go here, and this ray will go here. So we are going to get a wavefront. This one is known as spherical wavefront. Okay, how to convert into spherical wavefront like this. Okay. Here we can say same ray coming like this, you know, ray coming like this will go here. This ray will coming like this will go here. So here also you can say, okay, but it will take the shape of this sphere. Okay, so a spherical wave front, okay, of radius r by 2. Okay, so these three diagram, out of these three diagram, they can give some, okay, and they can ask which one is correct, which one is wrong. Okay, here coming, here it will, okay, like this, it will remain plane because this surface is plane. Here this surface is, okay, spherical means curved, so it will be also your spherical wavefront. Here also your curved, so it will be spherical wavefront. Now, this is the about okay. So two sodium lamp. This question they have asked earlier. Two independent sources are not coherent. Two independent sources are not coherent. Okay. Keep this thing always in the mind. Okay, the two sodium lamp, even though they have same frequency, okay, even though they have same frequency, two sodium lamp, if two sodium lamp illuminate two pinhole, the intensities will add up. Okay, I1 plus I2. Here we'll get I1 plus I2. Here also I1 plus I2, I1 plus I2. Okay, no interference fringe will be observed on the screen. Okay, pattern will not be there. For the pattern, it how to be, okay, it how to be what? It must be always coherent. Okay, coherent is always needed. Okay, all the time coherent is needed. Okay, maybe this question from the your diffraction kept taken from the, okay, listen, in the diffraction, maybe some more slides were there. They are saying that if you increase the, okay, pinhole size of the hole, if you increase the size of the hole, then what will happen? More light will go. Okay, and if more light moving, if more light going, then you can say 100% this is correct. Okay, intensity will increase if size of the hole increases. Okay, earlier hole was like this, now hole becomes more light will go, so intensity will increase. Then we have to say more, one more option, that what about the your size? Size is basically equal to, if you know that, 2, okay, 2d lambda by a. This is the size of maxima. Okay, size of primary maxima. If you remember, the size of primary maxima is simply 2d lambda by a. As a increases, size decreases, width, size, or we can say width. So width of primary maxima, which is the 2d lambda by a, as a will be more, okay. If aperture size is more light will go. More light will go means we can say intensity will be more. But if more aperture is there, size, or we can say width of the maxima will decrease. Okay, so A and okay, B, both options. Okay, remember this one. Okay, for the diffraction, important question. Okay, they will change the options when they have to ask, because in our examination only one will be correct. Okay, now this is again from the your okay, exemplar. They are saying light diverging from a point source. Everyone knows that light diverging from the point source, okay, it is, okay, always going like this. Okay, in all the direction will be going. If going in all the direction, then 100% we can say wave front is spherical. And if wave front is spherical, we have to write the intensity. Intensity will be energy on unit area, unit time, is energy by 4 pi r square into t. Energy is always proportional to 1 by r square. Okay, for point source. Remember, for point source. Okay, in the next chapter of EM wave, I will tell about the line source. For point source, 1 by r square. 1 by r square. Okay, so intensity decreases in proportional to the distance squared. Yes, correct. Wave frontage parabolic, wrong. Intensity at the wave front does not depend, wrong. Okay, we can take here answer A and B. Okay, clear? Now they are saying discuss the intensity of transmitted light when a Polaroid sheet is rotated between two crossed Polaroids. Okay, so here we can write this one is the one Polaroid, and there is the another Polaroid like this, and between this, okay, I am rotating. You know that if I rotate this Polaroid, I think this one is okay, clearly known to you. In one full, right now there is zero. Okay, like this I can say right now zero intensity. After that, if you rotate, intensity keep on increasing, keep on increasing, keep on increasing. When parallel, it becomes maximum. Okay, like if I take this thing here, okay, like this, if they are parallel, it is the maximum. Okay, if you rotate, minimum, cross means minimum. Okay, again parallel, maximum, again cross, minimum, again parallel, maximum. In one full rotation, 2 times max and 2 times min. You remember, in one full rotation, 2 times max and 2 times min. Okay, and when it is the maximum, when your cos square theta will be maximum, and cos square theta is always maximum at the 45-degree. So remember, the transmitted intensity will be maximum at theta equal to pi by 4. Okay, yes, and okay, in one rotation, 2 times max, 2 times max and 2 times min. Okay, 2 times max and 2 times min. This is the one question and this is the one question. Okay, they are saying in this one that okay, so at the 45 degree we'll get the maximum okay intensity. Now this is the question from YDSC. One question that I was feeling okay, that it how to be asked from the intensity, and this is the one question. Yes, a strong feeling for this question. Read this. Okay, I will spend some time in this one. They are saying light of wavelength lambda, intensity of light at a point where part difference is lambda h k. Part difference lambda h k, it means this is the maximum, na? Means maximum intensity is what? K. Where part difference is lambda, it means that is the maximum. So what is the maximum? Maximum is K. Okay, maximum is K. They're asking where part difference is lambda by 3. Part difference lambda by 3, lambda is equal to 2 pi. So 2 pi by 3 is the phase difference. Okay. They're asking intensity. You know, formula of intensity is always this. I max cos square phi by 2. Probably everyone knows this one. I equal to I max cos square phi by 2. Formula should be remembered by. Okay. Here I maximum is how much? K. I maxima is K, because they have given where part difference is lambda, intensity is K, it means that is the maximum. So K cos square, and how we got this thing, because lambda is always how much? 2 pi. You know? So 2 pi by 3 into 2, this becomes K cos square pi by 3 cos 60. What are the cos 60? Cos 60, 1 by 2 square will be 1 by 4. So this becomes K by 4. Okay. Do this question. Data may change, but the question will be there. Okay. 100%. Like this similar one question you will find in the examination. Okay. So many questions. Okay. Means will be there. Like 130 slides almost taken around 130 questions. 40, maybe 45 may appear. Okay. Depends on your luck also, my luck also. Okay, this is clear. Okay, this formula you have to remember. Data might change. They have given part difference is okay, lambda, then intensity K means that is the maximum. So I max means K cos square phi. Okay, phi we can say lambda by 3. Lambda will be 2 pi, 2 pi by 3. 2 pi by 3 into 2, 2 cancel, pi by 3. Okay. Then comes here semiconductor electronics devices and simple circuit. Logic gate they have deleted from the NCRT, but I have taken some questions from the old NCRT. Okay, but you will practice. Okay, they have deleted, does not matter. Okay, now coming to this one. And listen, semiconductor is the chapter where I say that you should read full NCRT. Okay, and you know that in the if I have to explain, then it takes 6 hours to take the full NCRT. That's why in the class I say always you should read full. Still, I have taken important points, okay, from there. So let's see. First is this graph, okay. This first one is saying about here, okay. This one is the your I can say in this one valence band, okay. This one is the valence band, and this one is the conduction band. And this gap is known as your delta Eg, which is known as forbidden energy gap. Okay, this gap between the conduction band and valence band is known as delta Eg, forbidden energy gap. Okay, in this gap, electrons not there. Either electrons in the valence band, either they are in the conduction band. Electrons in the valence band are okay taken as bounded electron, and once electrons are in the conduction band, they are treated as free electrons. Of course, free electrons will be having more energy as compared to the bounded. That's why energy level of the conduction band is okay slightly higher than this valence band. Energy required to make electron free is known as band gap. You can say band gap is nothing but the energy required to make electron free. Okay, energy required to make electron free is known as band gap. Energy required to transfer electron from VB to CB is known as band gap. If you are increasing the temperature, then band gap will decrease because requirement of energy will be somewhat less. If you are at the higher temperature, of course requirement of this energy to transfer electron from valence band to conduction band, okay, somewhat less, because already you are giving some energy using the temperature. So they can say temperature more, band gap less. Band gap is nothing but the requirement of energy, okay. In case of conductors, okay, this is the graph for conductor. In case of conductor, you know, already free electrons are there. There you don't have to give any energy to make them free. Already free electrons exist. Free electrons already there, so there is no amount of energy needed. That's why here band gap in the conductor is almost zero. Remember this thing, band gap in case of conductor is almost zero, no energy needed, okay. If we talk about the semiconductor, in the this graph is for semiconductor, here energy requirement is there. This gap is less than 3 electron volt, means energy needed but not more, okay. Requirement is not huge, requirement is less than 3 electron volt. So you'll remember, whenever gap is less than 3 electron volt, will keep in the semiconductor category, okay. Less than 3 electron volt you will keep in the semiconductor category, and the insulator category, okay. Diagram should be remember here. This requirement is more than 3 electron volt. Whenever requirement is more than 3 electron volt, you will keep in the insulator category, and huge amount of energy is needed. You can make the electron free, but a lot, okay, huge energy needed. Like if I say for the diamond, around 5 electron volt energy is needed. So less than 3 you will keep in the semiconductor. Like if I say for the silicon, 1.1 electron volt, germanium 0.7 electron volt, these are the energy required. Very, very less energy is required. So based on the band gap, you should be able to differentiate. Here no gap, here gap less than 3, here gap more than 3, okay. Now then this is given for the p type and n type also, okay. Now they are saying in this one that okay, if you talk about the 0 Kelvin, at the 0 Kelvin they don't have any energy to move from okay, valence band to conduction band. But if you increase the temperature, they can be easily okay, this, if you are at the room temperature enough energy is available, that electron can easily reach, they can break their bond, they can easily reach to the conduction band, okay. So this is the your okay, in this one you can see here what is more in this diagram, okay. In this diagram, these dot, okay, these represents electron. You can see here electrons more means this should be 100% n type. This is the n type, okay. And here you can say this, okay, white means your gap is there, okay. These are known as holes. Here holes more, and holes are always in the valence band, okay, and electrons, free electrons in the conduction band, okay. We can say this is the your p type, this is the your n type, okay. So first of all, from the diagram you should be able to identify, okay, holes more, here holes are more, that's why it is the p type. Here electrons, here only one free electron, na? One free electron, and here so many free electrons are there, that's why this is the n type. One more thing you have to remember, this is dot line. If you see here, this is known as energy level of acceptor. Energy level of acceptor is very, very close to the valence band, okay. Here acceptor atom we add, acceptor like we add the trivalent, because trivalent means they have only 3 electrons, so they have to make their bond, fourth bond, so they will accept, okay. So here acceptor, okay, trivalent acceptor we are going to add in this one, and energy level is close to this one. This dot line, you have to remember, energy level is very close to the balance, but they are going to accept from the balance only, okay. Here we are going to add pentavalent donor, okay. We are going to add pentavalent donor. What is the meaning of pentavalent donor? They have 5 electrons, and if they have 5 electrons, then out of 5 they cannot use all 5, they can only use 4. So this fifth one is extra. Fifth one they have to donate. They will say to fifth one, go wherever you want. So this fifth will say, I will become free. Becoming free means going to the conduction band. That's why here your more, okay, free electrons are there, and they can easily become free when this level is close to the conduction band. So these two dotted lines should be remembered by everyone. Here energy level of acceptor is close to VB, and their energy level of donor is close to ED. They may go the diagram, and then they can ask out of this which one is correct. 4 diagrams will be given to you out of this. Yes. Now, coming one question here, that pure silicon crystal has this atom, okay, means we can write this is the number of silicon here, okay. It is doped by 1 ppm. What is the meaning of 1 ppm? That in the 10 power 6 silicon, I am going to dope 1 arsenic, okay. 1 arsenic in the 10 power 6 silicon. You can say, sir, 1 silicon, how much? You can say 1 silicon, how much? 1 by 10 power 6 arsenic. How many are there here? You can say 5 into 10 power 28, okay, atoms are there. So in these, how many needed? 1 by 10 power 6 into 5 into 10 power 28. You can write here, it becomes 5 into 10 power 22 arsenic, okay. Now these many arsenic we have, okay, added. Now you need to tell me arsenic will give arsenic is trivalent or pentavalent. This thing you have to say. Arsenic is trivalent or pentavalent. Arsenic is pentavalent, and if this is the pentavalent, then these many electron it will donate. So number of electron becomes equal to 5 into 10 power 22, okay. So these many electrons are there. In the question, they're asking number of electrons. Number of electrons we got 5 into 10 power 22. We need to find number of holes. We can say number of hole equal to, we have this relation Ne into NH equal to Ni whole square. So we can write NH equal to Ni square divided by Ne. Now, you can write here in this one, Ni value given, always given, this 1.5 here. So you can write 1.5 into 1.5 into 10 power 32 divided by Ne. Ne is 5 into 10 power 22. This becomes 0.3. So it becomes, okay, here 0.45 into 10 power 10, okay. And that's the same answer, okay. You can check here. I hope this question is clear. Very important question and very simple also. We have asked multiple times this thing in the means our examination, okay. Again, I will explain here. In 10 power 6 silicon, 1 arsenic we are adding. That is the meaning of ppm here. So in the 1 silicon, how much needed? 1 by 10 power 6. So 5 into 10 power 28 silicon, how many arsenic needed? You can use, okay, solve like this unitary method. 5 into 10 power 22 arsenic. This is the pentavalent. It will donate the electrons. So number of electrons will be 5 into 10 power 22. Ne into NH equal to Ni whole square. So NH equal to Ni square by Ne, and then okay, solving like this. Clear? Okay. Now, this is the one page actually I have taken here so that okay, you will read, okay, that this page you should read, okay. I have taken for this graph, okay, but this page, if you get the time, okay, I will explain one line here in this one. This graph is important, you have to remember. In this one, upper one is having more barrier, that is known as your reverse bias. Third one is known as your forward bias, and second is known as unbiased. Okay, like this you can remember, okay? Clear? Now, I am saying you to read this one, okay? Due to applied voltage, okay, this line, okay? Due to applied voltage, electron from n side cross the depletion region and reach p side. Listen, what is the meaning here? This is the your barrier. This side so many holes are there, and these sides so many electrons are there, okay. Here some holes there, but that is the minority. Here some electrons also there, that is the minority. When these electrons, okay, which are the majority here, when they reach this side, they will remain as the majority or they will become the minority. These electrons which are here, okay, when these majority, when they are reaching here, they become the minority. Means here minority increased, and this is known as minority injection, okay. Like you inject something, like some some medicine is there, something like this, okay. So we can say here your electrons are there as the majority, but when they reach here, they become the minority. So we say this process as the minority injection, okay. Minority we have injected the minority like this. Okay, same here, these holes which are the majority here, and when these holes reach this side, they become the minority, known as your minority injection. So this process is known as diffusion also. Okay, we know that when majority moving, that is known as the diffusion. Another name you can have, that the your minority injected. When majority moves and reaches other side, it becomes the minority, referred as minority injection. Okay, so this process under forward bias is known as minority carrier. Okay, they can give in the somewhere in the statement, okay, that this process under forward bias is known as minority carrier, okay, injection. Okay, so this word you have to remember. Okay, for this word I have taken full page here. Okay, now this is the one question from the your VI characteristic of the diode. They are asking about the resistance. Okay, now we know that in this one they are asking okay here, so we can say in the forward bias you can write delta V by delta I. Always remember, these are non-ohmic devices. Diode always non-ohmic devices, don't follow Ohm's law. Okay, they offer dynamic resistance, and dynamic resistances are equal to delta V by delta I, and this dynamic resistance is always equal to 1 by slope also. Okay, you'll remember this thing, dynamic resistance is always 1 by slope. Okay, so you can say R equal to here delta V, here 0.7, which is not written actually. So 0.7 to 0.8 means 0.1, and I changing 10 to 20. So it is okay, 10 to 20 means how much? 10 milliampere means 10 power minus 3. It will go upside. Answer will be here how much? Okay, 10 ohm. Okay, so that is the 10 ohm they have calculated. Just 0.7 not written here. Okay, they have written in this one. Clear? And same in the reverse bias also. In the reverse bias, if you calculate, then you know in the reverse bias how much current is there? Potential is what? 10. And what is the current here? 1. So we can write in the 10 in the for reverse bias 10. Okay, potential current is 10 power minus 6. So this becomes 10 power 7 ohm. You can see here in the forward bias resistance is very, very less. So remember, forward bias offers very, very less resistance. Forward bias offers very less resistance, while reverse bias offers huge resistance. This 10 power 7 is the huge resistance. And if this much huge resistance is there, then current will not flow. That's why in the reverse bias, we don't take flow of current. We take flow of current only in the forward bias. Okay, in the forward bias, current is more. Remember, current is more. In the reverse bias, current is less. Width, resistance, barrier height. Width, resistance, barrier height, less in the forward. Width, resistance, barrier height, more in the reverse bias. Current, less in the forward bias. Current more in the forward bias, and current is very, very less in the reverse bias. These differences you have to remember. Okay, about the forward and reverse. Now this one is the your rectifier. Here for the rectifier diagram you have to remember, it is the half wave rectifier in this one. Single diode like this will be given. Okay, whenever you have single diode, you can say this will be the your half wave rectifier. This will be the your input like a positive. So positive cycle coming, negative not coming. Again positive coming, negative not coming. So you have to remember that here, that if input frequency is n, output frequency also n. In the half wave, input is n, output is also n. Efficiency in this case is 40.6 divided by 1 plus RF by RL. Okay, now NCERT is not saying anything about the efficiency. That's why chances might be less for the efficiency. Does not matter. Okay, a hot written. If input is having 50 hertz, output also 50 hertz. Efficiency you can keep in the mind 40.6 by 1 plus RF by RL, as well as this diagram. How you will identify this diagram? Single diode, it means it is the half wave. Okay, and if they are keeping like this two diodes, whenever they keep these two diodes, okay, somewhere you see this diagram, two diodes, one diode here, okay, and one diode here. Okay, if they have given, then you can say yes, two diodes means I can go for the full wave, because they will give exactly as it is, whatever diagram given. What are the meaning of full wave? In this one, both diode will not work together, alternatively they will work one at a time. Okay, like this is the D1, this is the your D1 here, this is the D2. Okay, so for positive cycle this one working, then negative cycle this will work. So we can say this is the positive, this is the negative, positive and negative. So we can write here in this one that okay, like this is coming from D1, this is coming from D2, this is coming from D1, this is coming from D2. Here you remember input frequency, this frequency always important, and then output frequency. Okay, output frequency you have to take 2n. Okay, this is there. 50 hertz output will be the 100 hertz. Efficiency you will write 81.2 divided by 1 plus RF by RL, just double of this. Okay, this is the efficiency. However, okay, efficiency not given, so you will keep in the mind. Okay, graph is like this, two diodes is the identification diagram they can give and they can ask here. Last one is saying that this is the your output. Output is not the DC. Rectifier are converting okay, your bidirectional to unidirectional, or we can say your AC to DC. But if you see, this is not the perfect DC. To get the smooth DC, okay, to get a smooth DC, or to remove ripples, we use, okay, we use filter circuit. Remember, okay, what are the use of filter circuit? We use filter circuit to get the smooth DC output, okay, of high capacitance, okay, of high capacitance. Okay, remember this thing. In the rectifier, this much information is enough. This is the your one question I have taken from the your old exemplar. Okay, option checking you can do always. Whenever these questions are there, you will go with the option checking. New NCRT not given, that's why, okay, just added. Go with the option checking. Okay, so I'm not checking the options. Okay, you will do logic gate. Logic gate always important. Basic questions will be there. They have deleted now. Okay, if not asked, then let's see what will happen. But okay, you will revise that one. Okay, this is the easy question. Now let's see here. Okay, how to solve, not the tough one. Okay, like here I will, okay, right here A coming, here what coming, A bar coming, है from here we can say what is going here, B, what is going here, your B. So this is what your AB, and this is the A bar coming, so we can say this will be the A bar into B, and then summation is AB plus A bar B. B you can take common, so this becomes A plus A bar. If you remember, na, like A plus A bar is how much? 1. Na? So we can say B and it is the 1 is equal to B. Earlier this question was asked. Okay, same question is the B, means in which B is matching, that will be the answer here. Okay, so it how to be same as okay, you can say in this one B result should be equal to the B here, 0 0 1 1 0 0 1 1, like this we can solve. Okay, now nuclei coming. Calculate the, now 2-3 chapters are left, it will be quickly done. Okay, calculate the energy required, okay, equivalent to 1 gram of substance. We can say energy will be equal to simply mc square. M is the 10 power minus 3, c square will be 9 into 10 power 16. This is the energy. If 1 gram of matter is converted to energy, there is the release of so much amount of energy. How much energy is there? You can say 9 into 10 power 13 joule of energy will be released. Okay, now we are left with just okay, 15 slides. Okay, now this is the diagram you have to remember. I will say 3 points in this one. Which one is the most stable? Most stable is the iron. Okay, around 8.8 MeV. Average binding energy, okay, per nucleon will be around 8 MeV. 30 to 170 most stable. Remember this one, 30 to 170. Okay, this range is the most stable. Okay, these 3 points, and these maxima and minima, these peaks confirms electron like structure, electron like cell subcell structure. maxima and minima conforms electron-like cell subcell structure for the proton and neutron. Proton and neutron are not just filled inside the nuclei, they have different energy levels. Energy levels of the electrons we know now well defined. Same as this, your proton and neutron also have the definite energy level, which confirmed by these peaks, maxima and minima. So remember these 4 points: 30 to 170 most stable, because the graph is almost linear in the 30 to 170 range. Maximum 8.8, average 8, maximum minima conforms cell subcell structure, energy level structure for electrons. Now next one is given here. Heavy stable nuclei have more neutrons than protons. Okay, heavy stable nuclei have more neutrons than protons. This is because of the fact, okay, neutrons are heavier than protons. Statement is correct, but not the region. Okay, what happens basically if you take very heavy nuclei? Okay, now in this one, this is the neutron, this is the proton, neutron, proton, neutron, proton, neutron, proton, neutron, neutron, proton, neutron, proton, like this, na? Then all this proton, okay, all these proton will have the repulsion. Even this proton also will have the repulsion, because your electrostatic repulsion, okay, is not short range force. It is valid for all the range, but only these nearby neutrons, okay, only nearby neutron will participate in the what? Only these neutron, okay, which are near, will participate in the attraction. Okay, only here. These neutrons will not participate in the attraction. What will happen as a result of this? Your repulsion becomes more, because in the repulsion, all proton participating in the repulsion, but all neutron not participating in the attraction, all proton not participating in the attraction. Repulsion becomes more, nuclei becomes unstable. That's why we have to increase. We cannot increase number of protons. If we increase number of proton, again more instability will be there. So we have to increase number of neutrons. So we'll increase number of neutrons. So at least in here, concentration of neutrons will be more, and your attraction force can be more. It will be balanced. Now we'll see electrostatic force between the proton are repulsive. Of course, this is the region, that's Vi. We have to increase more number of neutrons. We cannot increase the proton. That will be the correct region. Neutron decay into proton through beta decay. That statement is correct, but not the correct region. Okay, not the correct region. Nuclear forces between the neutrons are weaker. This is 100% wrong. So we can say this is wrong. Okay, but this one is correct statement. This one is correct. This one is correct. ABC correct, but ABC correct, but correct answer is only B. Correct answer is only B, because correct region is only B, because we cannot increase number of protons. Protons are having the repulsive force. We can increase the neutrons. Neutron don't participate in the repulsion. They only participate in the attraction. Okay. Now, it is found experimentally that 13.6 electron volt is required. 13.6 this is they are using a little bit fancy language here. 13.6 electron volt means this is the ground state, first of all. And if it's the ground state, okay, in the nuclei, those 5-6 questions that I have told are okay, very important. Binding energy questions important, that graph important, and that okay, whatever. I have not taken more questions because NCERT not giving more questions. 5-6, okay, taken there. So ground state, they are asking what is the velocity. Radius, in the ground state is 0.529 n square by z. For the ground state, we can simply write 0.529. You can round off 53 angstrom. Velocity, we can say it becomes 2.18 into 10 power 6 z by n meter per second. For the ground state, we can say 2.18. Okay, you can round off 2 into 10 power 6 okay, meter per second. That is written here, 2.2 10 power 6. Okay, we have used direct formula. They are solving. Okay, you can always use direct formula. Use direct formula, not like this. Okay, 2.2 into 10 power 6. And here they have given the radius 5.3 into 10 power minus 11, which is the same. Okay, don't go by these. Okay, these are quite scary calculations. Simple, directly R and V we can use here. Okay. Now this is a very important point here. Okay. They ask what are the spectrum of hydrogen. Spectrum of hydrogen is line spectrum. Okay, line spectrum. But once it cross infinity, okay, once it is crossing this infinity, then it becomes unbound. Unbound means free, and free electron can have any energy. Means after that it becomes continuous. Okay, so if they are asking question spectrum of hydrogen atom, then it is the line spectrum, answer as line. But if they're asking for the free electron, then free electron in the continuous, it can have any value of energy, only for the free electron. Okay, once it reaches the infinity, it becomes free, it can have any energy. Okay, now I have written here in this one some more data that you have to remember, because you know velocity, you know that is the your z by n. Radius, you know that is the n square by z. So I have written here angular speed. What is the angular speed? Omega, which is equal to how much? Omega equal to how much here? V by R. So you can say V z by n, and R is n square by z. So omega becomes in this one z square by n cube. You will remember this one. Omega is z square by n cube. Omega is also 2 pi f. That's why frequency we can say z square by n cube. And time period, if they are asking, then we can write here time period will be 1 by f. So n cube by z square. You have to keep this thing in the mind. Okay, same is written here angular momentum. Yeah, that you know. Current, if they are asking, then current is your simple. Okay, current is always charge by time. Okay, so you can say current will be proportional to charges. Okay, time. So we can write it will be 1 by t means z square by n cube. Okay, if they are asking magnetic moment will be your directly proportional to n, and then magnetic field z square. Okay, this is the magnetic field. Okay, magnetic field equal to what? Mu naught I by 2r. Okay, so we can say B proportional to I is what? Z square by n cube, and R is how much here? N square by z. So B will be proportional to z cube by n power 5. Okay, so these sometimes they can ask ratio based question. What is the ratio of current? What is the ratio of magnetic moment? What is the ratio of magnetic field? Okay, so if they are asking anything, you will keep this thing in the mind. Okay, now comes here question from the photoelectric effect. Frequency given here. Okay, they are saying this is the frequency, and they are asking power is this, and what is the energy of photon. If they are asking energy of photon, you will use this formula equal to h nu. So equal to h nu means we can write here 6.6 into 10 power minus 34, and frequency is 6 into 10 power 14. We got the answer. Okay, they are saying how many photons, and whenever they are asking the number of photon, means you have seen this formula. Remember this formula always for the number of photon: 5 into 10 power 24 p lambda. Always important. Remember this formula, because if this way you will go, it will take a lot of time to calculate. So for the number of photon, always remember 5 into 10 power 24 p lambda. So we can write here 5 into 10 power 24. Power is given here 2 into 10 power minus 3, and lambda is just c by nu. I hope you can put this thing. Yes. So always remember 5 into 10 power 24 p lambda. Now 10 more slides left and this will be over. Okay. Work function is given here. Work function is this 2.14. Find the threshold frequency. Okay, you can say threshold frequency. Simple. Work function equal to h, nu naught. We can write nu naught equal to w by h. Okay. The wavelength. Okay. Stopping potential given. Okay. Wavelength of the incident light. If they have given the stopping potential, listen. Stopping potential given how much? 0.6 volt. It means what is the kinetic energy? 0.6 electron volt. Work function is how much? 2.14 electron volt. We can say energy will be equal to work function, okay, plus Ke, which becomes in this one, okay, 2.74 electron volt. They are asking wavelength. You will use this one, lambda equal to 12400 by 2.74. Okay. Yes. Clear? Okay. So don't go by these calculations. These NCRT calculations are very lengthy calculation. Okay. Now, next one is given here. What are the de Broglie wavelength associated with electron moving with the speed of 5.4 into 10 power 6? You can see de Broglie wavelength is nothing but the lambda equal to h by m v. You have to put the data here easily. Okay, we can do the calculation. Okay, simple, h by mv. Now, next is, okay, this question, important question. Here, de Broglie as well as magnetic field, okay, from the exemplar of this question. Electron is moving with the initial velocity v equal to v naught I, and in the magnetic field b equal to b naught j. You know, when electron enters into perpendicular magnetic field, if electron enters into perpendicular magnetic field, its speed will not change. Speed will not change. I hope you know this thing. And if speed not changing, then lambda equal to h by m v. Speed not changing, then lambda will not change. So you will remember, speed will not change, so it remain constant. De Broglie wavelength, if it enters into magnetic field, it will not change. In electric field, if it moving, then it can change depending on the acceleration or de-acceleration. In the electric field, it can change, but not in the magnetic field. Electric field, they have already asked, so I thought they may not repeat again. Magnetic field not asked, that's why taken here. In the perpendicular magnetic field, if electron enters, its speed not changed. Speed not changed, de Broglie wavelength will not change. Okay. Direction changes. This magnetic field will change the direction, not the speed. Okay, direction will change. Now, in the EM wave, first of all, these equations should be very clear to you. You have to remember, first one is the your Gauss law. E dot dA is the your flux, Q by epsilon naught. For the magnetism, this is not there. It is the 0. E dot dl minus d phi by dt, and B dot dl is, okay, your, and this one is only your modified version. Okay. Now, this is the first example from the EM wave. A plane electromagnetic wave of the frequency travels. They have given here electric field is this. What are the B? Always remember, E by B is always equal to C. Okay, E by B is always equal to C. So they are asking the B, so we can say B will be equal to, in this one, E by C. So 6.3 divided by 3 into 10 power 8, we can say it becomes 2.1 into 10 power minus 8. And remember, they are always perpendicular to each other. Okay, they are always perpendicular to each other, means this one is what? X, this one is I, this one is J. It means this is going to be what? K. This will be always K. Clear? Okay. Now, same is this question. Okay, they are asking the exactly same one. That, okay, always remember that this thing always be same. Okay, this thing will be same. What will only change? That's why here you say this thing exactly same. Only magnitude will change. Like this is the 2 into 10 power minus 7, because electric field will be what? B into C, 2 into 10 power minus 7 into 3 into 10 power 8, which becomes 6 into, okay, or we can say 60. That's why only 60 changed. This thing remains same. Okay, phase, they are always in the same phase. Electric field and magnetic field, again I will say one line here. Electric field and magnetic field are always perpendicular to each other, but in the same phase. Means whatever is there inside the sine or cos, it will remain same. Perpendicular but in the same phase. Perpendicular but in the same phase. This page you have to read by yourself. You have to remember the range. Okay. One question coming. One require 11 electron volt. Okay, to dissociate a carbon monoxide molecule into carbon and oxygen atom, then this will lie. You can say 12400 divided by 11. If you divide, it becomes how much? Roughly, if I say, you can say, okay, around, I can say this is the 121. 121 means how much? 11. Around this, and this will be 100% in the which zone? You can say 100% in the your UV, 1100 angstrom. Now, before 3000 angstrom, before 3000 angstrom, everything is in the your UV. Okay, so we can say this will be in the UV. Electron 11 electron volt is quite high energy. It will be in the your UV. Okay. Next one is coming. EM wave radiates dipole antenna. Listen, antenna, dipole antenna is like this. This is like your okay, line source. Okay, and we know for the line source intensity will be energy by area into time, and here we can write it will be the 2 pi RL into T. So intensity is proportional to 1 by R. This will give you cylindrical wave front. Okay, cylindrical wave front. Remember, one is the point source I said, and one is the line source. I proportional to 1 by R. Okay, line source gives the cylindrical wave front, and I proportional to 1 by R. Remember this one. Okay, previously I said about the point source. Now they are saying a plane EM wave propagating along X. If wave is propagating along X, it means E and B will be perpendicular to each other. Okay, so you know, first is not possible, second possible, this possible, and this also not possible, because X coming, X not possible. So these two options are possible. Means if wave is going in the X, then electric field as well as magnetic field can be only in the Y and Z. So Y and Z, these two combination possible. This is the last question again from the exemplar here. You are given 2 microfarad. Okay, how would you establish an instantaneous displacement current? You know, current is given by this formula I equal to C dV by dt. I given here 1 milliampere means 10 power minus 3. C given 2 into 10 power minus 6 into dV by dt. So now we can say dV by dt we have to find. So we can say dV by dt equal to, okay, this will go that side, so it become how much? 500 volt per second. Means if potential it changes at 5 volt per second, you will get this displacement current. Okay, so in this one we have taken question from the displacement current, one question from the spectrum, question on the electric field, magnetic field. Okay, what combinations are possible in this one? Okay, NCRT have deleted energy density, that's why not taken any question from the energy density. I was expecting that we'll finish this whole thing by 1:20, 1:25. 5-10 minutes is extra, but as per the time it is over. Okay, done. This file, okay, I will ask them to send. You will, okay, revise once more. All important questions are taken into this one. Okay, either from the your exemplar is there, either exercise is there, either solved example, either in the, okay, hidden. Okay, some questions are hidden in the text. Okay, bye. Okay, good luck. Keep on doing your work. Okay, yes, enjoy.